Thank you very much and welcome, and wishing all the best for all the participants for this training course. Thanks a lot.
Thank you, sir. Now I invite Dr. Luke St. the Chief of UNOSA Space Section, for his brief address. Over to you, sir.
Rajit, can you remove this from our own things are coming in the presentation mode. So either
Yes,
you
sir.
put this PPT
Dipanvita, can
or
you please remove this? Dr. St. Perry. I think he is not there. So Dipanvita, you may please take over.
he was here just now.
So he was here, but
There is some problem in mic, Arjit.
Look, can you hear us?
yeah. Sir, your mic is
muted.
we are not able to hear you. Dr. Luke.
Sir, your mic, please unmute your mic, sir.
Maybe Luke, you can rejoin it. Probably there may be some issue. You can leave the meeting and try to rejoin again. Dipanvita, remove this. We are seeing our own pictures in the share mode. Why it is happening so?
Dipanvita, you display only the PowerPoint presentation, not your screen. Remove your screen and then display only the PowerPoint presentation.
Put it in the full screen mode.
Yes, Dr. Luke, now your mic has come. You may please start your welcome address, please.
Can you now hear me?
Yes, sir, we can hear you now, sir.
Okay,
Yes,
I've reconnected on my phone. Somehow, Team on my computer was not working fine. Apologies for that. So, yes, good morning from Vienna. So I am Luc Saint-Pierre, Chief of the Space Applications Section, where we implement a large number of the capacity building activities of the UN Office for Outer Space Affairs. Including through a program that you may know of called the Program on Space Applications, which is celebrating this year its 50th anniversary. Through the program, the office has the honor to work closely with the Center for Space Science and Technology Education in Asia and the Pacific, CESTAP, and as well as with the Indian Institute of Remote Sensing. And I wish here to thank here Director Prakash Chauhan to host this training on remote sensing applications for crop mapping and monitoring with the Indian Space Research Organization. This event starting today is part of a short series of hands-on training following up the UN Austria Symposium on Space Applications for Food Systems that was held earlier this month, online also, and is a joint program put together between UN-USA, the European Space Agency, the Indian Space Research Organizations, and NASA. So over the few weeks, each agency is delivering similar training to what you're going to see the next 2 days. It's important to understand that this workshop and the focus of this training is on food security, on food systems, as the symposium in Austria was called, because it is connected to the UN Summit on Food Systems that was held just 10 days ago in New York. That was a long preparation by a lot of agencies, by most of member states of the UN, to really see how can food systems be changed, can be adapted to current conditions and current risk. So we believe that tools like Earth observation are critical in these effort to improve food security. This two-day short training program will provide an overview of remote sensing applications to agriculture and focus our understanding on rice crop mapping concepts, techniques, tools, and you will benefit from hands-on demonstration on image interpretation, processing, and even on modeling. Of course, and you probably know, there are so many approaches and techniques existing in agriculture using space-based solutions. But here you will have the opportunity to learn from existing services that with proven results and operational successes, helping agriculture and supporting agriculture all over India. So from what I've seen in previous opportunities, it's not only theoretical approaches, it is operational services that you will learn from. Finally, I trust that as participants, you appreciate also that offering innovative training programs online is probably as challenging as receiving the training. Okay, so of course we all need a bit of flexibility and to take as much from those opportunities. But here with the regional center, with IIRS, with ISRO together, I believe you are in very good hands. And I hope you will ensure individually to take advantage as much as possible of this extraordinary opportunity, and that hopefully will help in strengthening your own capabilities in Earth observation for planning and monitoring. So thank you, and hopefully you will have a good 2 days. Again, apologies for the little connection problem. Thank you.
No issues.
Thank you very much, sir. Thank you very much, sir. Now I take this opportunity to welcome Dr. V.K. Dadwal, who is the Indira Gandhi Chair of Environmental Science in NIAS. Now I would request Dr. Dipanvita Haldar to kindly introduce the guest.
Yeah. Good morning, delegates, our esteemed speakers, Director Steve, Chief of the Space Application UNOOSA, Dr. V.K. Dadwal. It's my great honor and privilege to introduce Dr. V.K. Dadwal. Dr. Vinay Kumar Dadwal has 38 years of experience in ISRO DOS and has extensively worked on the use of Earth observation data for a number of applications, including crop discrimination, crop production forecasting, land transformation, disaster management support, and the biogeochemical cycle of carbon. He has held many senior positions, including Director, Indian Institute of Space Science and Technology, Thiruvananthapuram from 2016 to 21, Director, National Remote Sensing Center, Hyderabad from 2011 to 2016, and Dean IIRS Dehradun 2004 to 2010. At IIRS, he was concurrently Director STEEP in 2006 and 2009-10. He has co-authored more than 300 peer-reviewed journals and co-guided 11 doctoral students. Dr. Dadwal is fellow of International Academy of Aeronautics, Paris, National Academy of Agricultural Sciences, New Delhi, Indian Meteorological Society, New Delhi, Astronautical Society of India, Bengaluru, and Indian Society of Remote Sensing, Dehradun. He was chair for Subcommittee on Science and Technology of UN Committee on Peaceful Uses of Outer Space, UN COSPAS, in 2016. Currently, he is Indira Gandhi Chair, Professor of Environmental Science at National Institute of Advanced Studies, that's NIAS, in Bangalore, India. It's my great honor and privilege to welcome you, sir, to give a talk, invited talk on overview of remote sensing and EO systems to our wider range of participants. So we have participants from all kind of background, from agriculture and all disciplines of science and technology. Over to you, sir. Welcome, sir. Dadwal, sir.
Dadwal sir.
Dadwal sir.
Please unmute your mic, sir.
Sir, kindly unmute your mic, sir.
Am I unmute now?
Yes,
Yeah,
sir.
yes, sir, we can hear you.
I am audible?
Yeah, yes, sir.
Okay, so good morning. Good morning, Dr. Prakash. Good morning, Pierre. Thank you, Dr. Dipanvita. So I would like to say it's a pleasure and privilege to speak to so many people who are interested in Earth observation and remote sensing. So I would like to share my screen and then bring in some varied aspects of remote sensing and Earth observation, right? So we start by is my screen visible?
No, sir.
Not yet, sir, not yet.
Not yet, sir.
Okay, let us try again.
Yeah, sir, it's visible. It's visible, sir.
Is the screen visible now?
Yeah, yes, sir, yes, sir.
Okay, so I have around now 45 minutes.
Yeah, right, sir. Yeah.
So now we are going to touch a large number of areas in next 45 minutes because it may not be possible for us to go into detail. So we would just introduce to the all participants the remote sensing and the Earth observation systems. Generally, a very simple definition which a textbook uses is the science and art of obtaining information about an object, area, or phenomenon through an analysis of data acquired by a device that is not in direct contact with the area, object, or phenomena. So this is remote sensing. But the practice of remote sensing started before the definition. And then this definition, it was simply realized that this remote sensing is done by all categories of scientists, from astronomers to a huge range of people. So that is why now we prefer to use the term Earth observation, and that too Earth observation from space. But people sometimes also say that there is a remote sensing, there is a aerial sensing and proximal sensing. It means your remote detector is very close to the object, or basically on the ground in hand you are carrying a sensor. We would concentrate on Earth observation from space in today's thing. So obviously what would happen? You have a sensor which has to be on a platform that is a satellite. The either the sensor should have its own power to irradiate the earth, or it has to depend upon sun. Now for the sun's radiation to interact with the target and reach, you will have perturbations including loss due to cloud. The satellite data must be then sent back to the earth through a communication channel, then it must be converted into a product and a information, and the information must be used. So this entire system is the Earth observation system. Okay, so is not only the sensor, is not the satellite, is not the processing technique, but from the end to end, that what objective you have, and with this data, what finally you are able to derive. So now it has become a very powerful tool, very useful for hundreds of applications, and we won't touch into applications, but just look at some of the issues. So why this sensor or eye in the sky is important? One, it can see large area. Two, it can cover each part of the globe repetitively. Since we will use electromagnetic radiation, we observe beyond the human eye. Human eye is only in the visible small part. Then, depending upon our engineering, we can get a range of spatial, spectral, radiometric and temporal resolution. I will explain to them. More importantly, we can actually have developed quantitative parameter for agriculture. It can be like leaf area or crop biomass, right? Or even the evapotranspiration. More important, the one satellite picture can be used for land cover, for forest, for crop, for water body, for urban area. So it is multi-thematic. It allows us to look at linkages. Now, since the data is digitally brought to the earth, it is stored, and if you have a better technique, you can go to the history and do a full retrospective analysis. That is the power. Plus, since you are covering the entire globe, you will observe areas where humans can't reach, basically the poles, the entire ocean, and even the third pole, like Himalayas and many over the forest, many large areas. Human beings are not present everywhere. So this is the power of the system. Now in the electromagnetic spectrum is now from high energy to long wave. What you would see is the atmospheric transmission is shown in the lower graph. Now, in the visible NIR and thermal, we tend to use or we prefer wherever the atmospheric transmission is high. If we take the bands where the atmospheric transmission is not high, then we would really get the constituent in the atmosphere that is called atmospheric sounding. So it is in visible NIR sphere channel, thermal at 11 and 12, and you would also see in the microwave band, that is from 10 millimeter to 1 meter, transmission is almost guaranteed. So that is why microwaves are used to look through the clouds and in all atmospheric conditions and in day and night to really observe the earth and derive many useful parameters. Let us simply take a look at the vegetation. So if we were to look in the visible or near infrared, we can actually create vegetation indices and get a leaf vigor. If we look in far NIR, we could really get a fluorescence. If we look in thermal IR, we will actually sense the temperature, which as the crop canopy does evapotranspiration, it cools, and we can actually measure the evapotranspiration. Once we do the microwave, depending upon the frequency, we will have different type of penetration. Either we can have the canopy biomass or even the entire canopy water column. There is another sensing, that is LIDAR, that will give us the height of the crop canopy vis-a-vis the background. So thus it is now clear that we can really study a large number of phenomena from the space. But the remote sensing or Earth observation technology is a very, very powerful and diverse set of tools. If we use small number of bands, maybe 3 to 10, 15, we get multispectral data. If we use 50, 100, even 200 type of bands, which are continuous and narrow, we can generate hyperspectral data. If we illuminate with radar, we get a synthetic aperture radar. When we measure temperature, we get the thermal effect. When we use atmospheric lidar from space, we will get particles in the atmosphere. And if we use NIR, the surface lidar, we would actually get the terrain. We can also see the emissions. So we can get the temperature, the brightness temperature of ocean and land. We can have radar directly underneath called radar altimetry, which can give us the sea surface height, waves, etc. Or we can look through the atmosphere to do the limb sounding. Or we can have a pair of microwave satellite where the distance is measured to very high accuracy. As they move, they are subjected to differential gravity, and we can even measure the gravity. We can measure the radiation reaching outside the Earth through irradiance photometry. And from a scatterometer, we can look at the roughness, especially ocean, which will give us the wind at the ocean surface, or we can even have the scatterometer over land, which will give us the roughness and water. So thus you can imagine a range of sensors, sensing and observation technology allows us to do a large number of remote sensing application. All this application we can do from sub-meter to hundreds of meter, different ground resolution. We can then also have different accuracy of the data. That is called the radiometric resolution. We can have at multiple times. That is called the temporal resolution. So with all this, what do you do? The goal of Earth observation or the remote sensing is the societal benefit, quality of life, whether it is disaster, sustainability, forest, so many things. So basically, the sensors give us huge amount of data in petabytes. Now that data is converted into products. Then products give us the even gigabytes of information that can be LAI, modeling, crop area, a large number of things. Now this information is actually converted into knowledge and an actionable item. Whether we have to sow the crop, whether we have to irrigate the crop, what is the likely yield of the crop, should we pay compensation to farmers? That is this knowledge which comes from this entire chain. Okay, and at each step in this chain, almost the three order you actually assimilate. So from petabytes to terabytes for data processing, terabytes to gigabytes for information, that to megabyte, and then only kilobytes is needed by the people who really have to act. So this entire system to work, not only you require the sensors or satellites, you have to make data accessible, right? It has to be given in time and cost so people can use. You have to develop the capacity of the people to really understand and use this information. That is why we are having a training program. Now, since there is so much difference in the capabilities and capacities, there are a large number of international efforts to really ensure best use is made of this technology called Earth observation or space technology. How has it evolved, So the photography developed in the 19th century and aerial flight at the beginning of the 20th century. So initially, it was mostly used for war, World War surveillance. So the cameras were there on the aircraft. Then what happens from 1946 onwards, we had rockets which could really cross over the Earth's atmosphere. And later on, the rockets were traveling from Earth to Moon. Rockets only gave oblique low resolution type of photography, which could really be done. 57 onwards, when we had the Sputnik, then US had a very detailed, reconnaissance program with a secret which was only released after 1990. It gave 1 to 5 meter black and white images. Now those images are available for retrospective analysis as Corona. And the civilian remote sensing started with Landsat in July 1972. Then many countries have done, and now after that came the microwave sensors. But the current era, there are more private owned Earth observation, satellite and data than the government agency owned. So now the Earth observation is truly becoming commercial private. Second, because of the various international programs and the access from the natural, the medium resolution and the meteorological data being made freely accessible, the entire humanity can gain from the Earth observation. So this, if you understand that where we are and how we have reached, I will just cover some more, with illustrations. These are 3 historical photographs. One is the view of Earth taken from V2 rocket in 1946. On the other, the east north corner, you have a mosaic generated from these oblique images. And the first image from a TV type of sensor put on Tyros, right, by US. So this is the first picture, April 1, 1960, where you can see the cloud. And this led to generation of meteorological satellites, right? From that to this resolution, which is of the order of around 30 centimeter, Maxar Technologies WorldView 4 satellite, right? Where you can see the building, the top, each vehicle, markings on the road, trees, lamppost, you name anything, right? So we have covered a huge distance in last 50 years and really truly made the Earth observation and remote sensing a very, very useful tool. So this is a further process, that image, to really create a 15 centimeter product for defense and security application, where you can read what is written on the runway. Of course, if you require better, you can always go for aerial photography and drones. But the space itself has reached almost like 15 to 20 centimeter, 15 to 30 centimeter type of images. When you are viewing the Earth from space, you will view a small area. So satellite can either have a wider view, or the camera can look across to cover, or the satellite can be made, the sensor can view from 2 locations the same place. So this allows us to generate the stereo pictures. So not only the flat picture, the 3D view is possible by this as well as LiDAR. I will explain to you. The multi-angle viewing, it also crosses different amount of atmosphere, right? So not only the surface, we can get detailed information about the particles, their number, their spectral properties, their asymmetry, etc. from multi-angle viewing. Plus, you can also get about the tree and vegetation canopy additional details. If you are able to see the same building is viewing at different times of the day at different angles by the Worldview satellite. So here you can see that even the interfaces and the shadow and so many information. Now, once you have this type of data sets, the processing also is equally then complicated, right? So we need to develop different type of processing techniques. So this is a summary only for NASA. Some of the major Earth observation satellite and what are they measuring. So you can see TRMM is measuring rain, CloudSat is measuring cloud moisture, OSTM is measuring ocean biology, Calypso is measuring cloud and aerosol, right? So then land cover, the snow, ice, soil moisture, you would really see the very large number of parameter. So including the fire, which is then seen, the ocean surface. So each mission with its sensor now can measure a different property, but it also means that we do require a very large number of sensors. And since we have to cover globe, so as of now, there could be more than 600 satellites which are doing Earth observation, right? Which are currently active. So this is an illustration from NASA. If you look with the timeline and what is likely to come in future, so Landsat 9 was launched about 3 days ago. So the color are showing atmosphere, earth surface, water and energy cycle, atmosphere dynamics, and climate change. So the future satellites include Clario for calibration, PACE, Glimmer, and the JPSS. So, and in 22, what you would see, lower bottom, if you can concentrate there, there is NISAR, which is NASA ISRO SAR. There is a SWOT to measure the interferometry of water. There is tropics, there is a geocarb to measure the carbon and tropics for forest biomass. So a large number of satellites and capabilities will continue to be available. This is only one. If you look at ESA and the European Commission, they have 3 categories of missions. There are meteorological missions which are done by EUMETSAT. So METOP and MTG, the Meteosat and MSG, Meteosat 2nd generation and Meteosat 3rd generation, they measure the clouds, water vapor, the sea surface temperature, wind, motion vector, gases like ozone, large number. Then the second category is the Sentinel mission. I will explain in the next slide. And third is the Earth Explorer mission, which are being developed for developing new technologies and doing the Earth science application. Important of them are EarthCare, Aeolus, Biomass, and Swarm, right? So they will measure respectively the atmosphere, the tree biomass, and the wind from the space lidar. If you look at Copernicus, it originally started as GMES, Global Monitoring of Environment, by ESA. Then it was taken over by the European Commission and named Copernicus. The advantage of this Copernicus is it is an end-to-end Earth observation system. So Sentinel-1 was launched in 2014. We have reached up to Sentinel-5. So these were radar, synthetic aperture radar. Day and night, 2 are there. Then Sentinel-2, which has 13 bands and 10 and 20 and 60 meter resolution, covers the globe every 5 days. Then we had Sentinel-3, which is on the sea surface topography. Then Sentinel-5P, which was on the atmospheric constituent. Then Sentinel-4, which is on the air quality, and many products, including the effect of COVID, was monitored through that. The greatest power is that all these data is made available free to the entire global community without any stoppage. So it is and the continuity is guaranteed till 2030. So I suggest one should really look, if you are doing a current application, to really look at the full suite of observation available from Sentinel. So these are the missions and their repeat missions up to the Sentinel 6 and 6A. So 2030 and beyond, this data is accessible and guaranteed. So you have global open access data. I'm sure some examples of this will be covered in this training. The France, it started with imaging from spot image. Then the spot image was privatized and now it is done by a private company, EADIS Estrium, as Pleiades is available as a dual military cum civilian. As of now, they have number of missions in altimetry and atmosphere, right? So the mission and the launch period are indicated in the panel below. So they are concentrating. The CNES also has collaborative missions with ISRO. One of them is Megatropics, which is on equatorial, and it measures the energy and water cycle. The second one is the Saral Altica. You will see in the altimeter, which is for the sea surface. And the third one, which is being developed, is Trishna. Trishna is important for your community because it will measure the temperature at a scale where agricultural phenomena, water use and evapotranspiration will be monitored. If you look at JAXA, JAXA's Earth observation is concentrating on a fully polarimetric L-band SAR. Also the GCOM missions, they also have missions in collaboration with NASA. So they are concentrating on carbon dioxide. Plus with NASA, they are concentrating on global precipitation mission, which is a virtual constellation to really do the rainfall mapping of the entire globe with a large number of satellites. So for agriculture, the satellite derived rainfall precipitation becomes another very important input where the ground-based observation system is not strong. The radar altimeters measure the sea surface temperature, and they are very important to study the rise in the sea surface. You can use it to really look at where the sea levels are rising, what are the areas likely to be under danger for inundation, the climate change studies, and so on. You can also use this data for large water bodies and also over ice for polar and east-west running rivers. We will skip this I would just like to show the Indian Geostationary Meteorological Earth Observation System, starting with INSAT 1A in 1982 to the now INSAT 3D and 3DR, and a large number of parameters are done. Similar are the one which are done by the NOAA through the GOES East and GOES West, by Japan through Himawari, and the EUMETSAT does through the MSG and MTG, which I explained to you. So the entire cloud, rainfall, cyclone, the wind vectors, humidity, temperature profile, and ozone are very important even in the agriculture context. The Indian missions have used a special 3-band, 3-tier configuration of high resolution at 5 meter, a 23 meter 140 kilometer swath LIS3 multispectral, and a 3 and 4 band very wide swath which has a repetitivity of 5 days, but at 56 meter. So here what can be done is you can monitor regional crop growth, planting, harvest, greening. You can use the LIS3 to really look at the field-wise information, identify crops, and you can at LIS4 data where you really have very small field and complicated farming and agriculture systems. This is the configuration of the SCATSAT of the ISRO, which measures the ocean surface winds and is a very important component for weather forecasting. This is the product from the Saral Altica, which allows us to do a lot of application. And this is the 2022 planned NASA ISRO SAR NISAR. Read it as 2022, which is a L-band and S-band SAR built by NASA and ISRO respectively. The launch vehicle and the platform is also built by ISRO. The L-band SAR is the JPL thing. It will give almost like below 10 meter resolution and interferometry and do global mapping. Now, there are two ways of looking at the data. One is either we can have model how radiation interacts with soil and canopy, and with multiple observation we can compute, or we can develop empirical regression. As of now, users don't have to worry because the space agencies and their various mechanisms are already releasing land cover, they are releasing leaf area index, fraction absorbed power, the optical, the volumetric water content, soil moisture at different scale. But there is a lot of science and mathematics that goes behind from the space observation to give that parameter. And also important for user is that they should calibrate it locally for their use. The other part, what has now become important and which is likely to become very important for the tree, biomass and carbon, is the growth of LIDAR. Originally a vegetation canopy LIDAR was planned, but it was abandoned. Then on ISAT, the glass on ISAT 1 and ISAT 2 had LIDAR. ISAT 2 specifically had 17 meter footprint and was accumulating data over 100 meter strip. Now JD, which is on International Space Station, is directly giving a waveform, and it is also as of now giving a tree height product. I think one product for the coverage of the International Space Station is available to the user. And something very interesting being developed with LIDAR is to really measure the methane concentration, which is the DLR Merlin mission. There are huge number of other opportunities which are slowly becoming. One of that is the GNSS remote sensing. Now, since we have so many GPS, GNSS satellite, and they go on beaming their signals, which interact with ocean and the earth. If we see their direct signal through the atmosphere or the reflected, right? So we can have GNS reflectometry and refractometry by just building passive receivers. So this is what it is showing. These type of receivers are being attempted by a large number of private commercial organizations also. Currently, to do better weather prediction, you have to send balloons which do the sounding, the vertical profile of temperature, humidity, wind. But with these type of sensors and already available GNSS, the entire globe, the 3D structure of the wind movement thermal can be seen, which will really make the weather forecasting even much more accurate. Now International Space Station has also become a very important Earth observation platform. JD I explained to you, it also has the photographic thing. Now you just remember, you must have seen the old computer, big computers. You must have seen the radios. So there is power of miniaturization. The same power of miniaturization is being brought to space technology. So one of that is a CubeSat, is a 10 centimeter, 10 centimeter, 10 centimeter type of a 1U. And now you have satellites with 3 such U's, they can really do high resolution imaging. So as of now, about 50% of the satellite launches have become small satellites, 50 kg and below. So this number is going on increasing. As you will see, the power of the CubeSat, right? The resolution is also going on improving. So slowly, as you will see, the Flock 1, which is blue line, which is less than 5 meter, right? It is giving very high repeativity and is giving resolution, which will now slowly start competing with very complicated and heavy high resolution satellites. So this is one such example. You are aware, or you must have heard of this company Planet. They really have large number of more than 200 satellites, right? Each one is either a small PlanetScope or a Flock or a SkySat. The Rapid Eye has been done. They really collect entire globe every day. So their coverage has actually become 300 million square kilometer per day. So miniaturization has reduced the launch cost, allowed mass production and very large deployment. So now at multiple observation time, the whole globe can be viewed. And then for agriculture, you can really use this multispectral data of better than 5 meter resolution. So this, I think, a new class of applications will develop. So these, in addition to the Sentinel and the NASA, there are a range of other websites which give free data. I thought I must share. So now what is going to happen? Even now we have reached about 50 petabytes of data. Now with so many hundreds of missions and the even NASA is assuming that their archive will actually, up to now it is 50 petabytes in so many years. From now onward, every year they are going to add 50 petabytes. Sentinels themselves download 5 petabytes of data. every day from Sentinel is being done. And we also talked about 300 million kilometer from planet's home. Now, when you have daily so much data, if it doesn't reach you same day, you can't do any application. So now, instead of selling data, now Google has come up with this and everybody has a website. So now the data is processed and kept there. You only have to log in from outside and run your code on your small area to get an output. So I'm sure as part of this training, this very, very powerful technology where everything from the data, its pre-processing, registration, everything hassle has been removed from the user. User only needs to go on the website for his area, run a specific code to extract what he wants. So this thing is continuing with large number of new missions, more integration, big data, decision support system, so that the entire, the goal of whether it is climate change, SDG or disaster is all met. Thank you very much. This was one, I think, a hurried overview of Earth observation. Thank you. If there are any questions or comments, I would be very happy to respond.
Thank you, sir. Thank you for the illustrious and knowledgeable talk covering every aspect of remote sensing and Earth observation systems in a very detailed manner. Definitely, it has enlightened our participants to a greater extent. And now we can have few questions from the participant side. You can raise your hand or you can type on the chat box. So, if anyone is having any queries, you can type on the chat box or you can raise your hand.
Thank you, Dr. Gopakumar.
Sir, there are some questions coming up, so I'll take them one by one. Vaibhav is asking, does ISRO has some open data that can be used freely by anyone at global scale?
Yeah, so the Saral Altica data is open. The SCATSAT data is open for globe. The old OceanSat archival, which was done, is open. The AWIFS data, which is acquired by NASA in US, is open. Plus, in addition, Bhuvan and Vedas portal have large number of open data sets over India. It includes DEM, it includes the LIS3 data as well as the AWIFS data. It has many GIS layers, 6,000 interpreted GIS layers of land cover, water, disaster, urban, which can all be called by OGC WMTS, GIS commands. So there is a huge amount of data. I am sure somebody will cover it up.
Yeah, thank you, sir. Sir, another question Amrit is asking, some tools and open source software.
Okay, so the CEOS is maintaining a page. As of now, many image processing software have become open source. I think if I name one, others will get missed, but still I would like to say QGIS, the current version, which is integrated with GRASS image processing, and also it is integrated with Postgres SQL. So you could really do this entire set of things. For small areas, you can even use Google Earth Engine. Only for commercial, you may have to pay. So there are actually NASA for each of their missions has software, right? You can even use the Panoply and many other software. The ESA, European Commission, have given separate toolbox for each of their mission, whether it is for ocean mission, atmosphere mission. There are special open source software which are for interferometry and SAR data. So there actually is a whole bunch of open source software available to handle every problem of Earth observation.
Thank you so much, sir. Thank you for the excellent and detailed lecture. Any more questions from the participant side? You can raise hand and ask also, or you can type in the box. Sir, one more question has come up. The open data can be misused. So what are the strategies to avoid the misuse of the data?
There are two categories of data which are called real-time high-resolution data for security applications. Right? UAV imaging rest of the country. So this concept of security, while it is a major concern, but because given the advantages, commercial and human society and development, people are still moving towards the open data. Come now, you could really merge those, though they are points, you could really intelligently merge with other high resolution data, because space lidars are giving better than 20 centimeter absolute accuracy. So with stereo images and other data you can do. The interferometry, if you can generate, you can really do centimeter scale variation again. So Just readily available are SRTM ALOS globally. Over India, the Cartosat-1 mission, commercially the TandemX. But if you can be innovative and work for your areas, you have numerous possibilities.
Thank you, sir.
Thank you.
I would
Thank
like
you
to
very much.
thank you, sir, again for the illustrative and very knowledgeable talk. It would have definitely reached to the participants, and many of them are like youngsters and newcomers, so they would have got a very broad overview and very nice talk, sir. Thank you once again
Thank you, everybody.
from the organizers. Thank you, sir. So we'll have a short tea break for 15 minutes now, and then we'll have the next talk on remote sensing applications of agriculture. So we'll meet back around 11:20. 11:20 we'll again meet back. Thank you. So welcome back, participants. We'll start this post-CAT session now. Am I audible?
You are audible for me, Deepamita.
Okay, sir. Okay. So now we have the talk on remote sensing applications of agriculture by Dr. K.R. Manjunath. He is Scientist Engineer G and Associate Director Agriculture for Earth Observation Applications and Disaster Management Support Program Office, ISRO. He has an immense number of field of expertise involving remote sensing and GIS applications of agriculture, agro-ecosystems and agro-environment, contributions towards development of techniques, methodology, applications, project conceptualization, formulation and implementation, RS and GIS based crop area production using optical and SAR data, cropping system and agro-environment studies, hyperspectral remote sensing, greenhouse gases from agriculture. His major achievements involve the development of procedures and techniques of pre-harvest crop production estimations using satellite data, collateral data and meteorological data for major crops like wheat, rice, grain sorghum, mustard, potato through digital image processing and crop yield models. He was a part of the SAR rice studies in India and National Kharif rice acreage estimation project. He has worked on cropping system analysis and demonstrated the utility of IRS LIS3 and WIPS and AWIPS data to derive seasonal cropping pattern, crop calendar, crop rotation maps. The specific use of remote sensing based rice area derivation and stratification in GIS environment for large area sampling, coupled with field data and extrapolation towards generation of spatio-temporal methane emission maps and non-point source pollution. He has worked on hyperspectral remote sensing of the vegetation also and has been the lead for Fasal and Chaman projects at SAC. He has been the recipient of many awards, to name a few: the prestigious P.R. Pisarotti Memorial Award for Young Scientists by Indian Society of Remote Sensing during 2006, ISRO Award for Excellence and Geospatial Award. He has been the member secretary of Standing Committee on Agriculture and Soils and also the ISRO Geosphere Biosphere Program. He has immense number of publication, around 75 scientific reports and papers and chapters in the book Wetland Agriculture as a co-author in the Manual of Remote Sensing. This is a very important book and many beginners and workers in this field, they refer this book usually. And he has given many invited lectures, training and presentations for faculty and delivered about 70 lectures. He has imparted training to the UN ESCAP training on capacity building to the other faculty and students of remote sensing. He has been reviewer of many scientific international and national journals and member of technical and seminar committees and also chief editor of Indian Society of Remote Sensing, Ahmedabad chapter newsletter, member of panel of experts for JRF in SAC, focal person of Respond and member secretary of IGBP. He has guided many students and scientists for the geoinformatics related work and is a member of professional societies to include, name a few, ISRS, ISG, IMSA and INCA. So we have our privilege and honor, sir, to have you here to deliver this talk. Over to you, sir.
Thank you very much, Dr. Deepamita, for all the nice words that you have used. So shall I share my screen now?
Yes, sir. Please share.
Okay. Kindly tell me whether you are able to see my screen.
Yeah, it's coming. Yeah. It has come, sir. Coming. It's there. Yeah.
Okay. So I'll go to the full view mode, and so with this, this one morning we had a lecture about the different EVO systems, its use, its diverse, how it has evolved over a period of time, and what is the range of the systems that are available for various applications, etc. So with that background, now we are moving towards the very specific component of the applications, that is the remote sensing applications of agriculture. So what I will be doing in the next about 40 minutes or so is I'll just give a very quick view about the importance of the agriculture, its use of technology in the agriculture with special reference to the remote sensing and why it is required and what are some major global programs that are available. Just will touch on this point. Then which are the major areas of the agricultural aspects or issues that could be addressed and how it has evolved over a period of time. Then primarily, what is the basis of crop production estimation? As you are aware that it's having two components, area and the yield, how each of these could be addressed with and additional inputs of the remote sensing. Then we'll look at the important aspects that do concern us, that is related to the drought, then the damage assessment related to the pests, diseases, etc. So I will just quote some examples that are available. Primarily, most of these examples could be from India. And biophysical parameter retrievals, horticulture applications will also look into some of the sustainable aspects of the agriculture through the cropping systems and agro environments. Then finally, we'll have a discussion at the end. So I think this is what I'm going to cover in a nutshell. Let me just give, before we actually go into that, usually why we have to use the remote sensing for the agriculture. Agriculture itself, if you look at it, it's such an important domain that it is one of the second largest source of employment for the people. And it's not only for the sustenance, but also for the economics of it across the globe. And primarily we depend on agriculture for anything and everything. This is how actually we have evolved over a period of time. So primarily it's about 5 billion hectares are there, and about 38% of the global land surface is used for agriculture, and nearly 10% is covered with the permanent the crops like primarily the fruit crops, the oil palm, cocoa plantation, like that. And water is important aspects, and nearly about 20 to 21% is irrigated area. And production of the primary crops itself, it's account to something like 9.2 billion tons. Many of the numbers that have been put here, they are not sanctosanct because these are primarily based on different sources, different estimations. So these, there could be some minor variations. If you look at the global croplands, India, USA and China, they share about 11, 10 and 9% of the area for the crops. As I said, it's the second largest source of employment, and the areas of and the sources of irrigations do vary. It also supports a lot of industries related to the pesticides and fertilizers. Then, of course, seeds. Then there is an export of the food exports, that is global food exports itself is accounting to about close to about $1.4 billion. With all these resources, we also have some challenges. So the important challenge is the per capita land, which has reduced over a period of time. Now it stands a little more than 0.2 hectare. Then there are issues related to land degradation, salinity, and those issues are propping up. Then a lot of fertile soils are being lost. Of course, we have to support with the same land more and more, set up more the population. Population is increasing. Then agriculture is also one of the important the component that uses the fresh water withdrawals. Nearly 70% of it is being used. The over a period of time which has evolved recently, of course, in the last couple of years, is the loss of labor. So agriculture labors, they are going away. Hence, we have to use many sensors, technologies for other technologies to meet this challenge. Then there is a diverse climate, and not only that there is a diverse climate that is both advantage as well as a disadvantage, and at the same time it is also subjected to climate change. So agriculture is vulnerable to climate change. We'll look maybe a little bit into this. Then it's also the source of one of the often accused as the the part of the GHG contribution. So apart from this, there are a lot of uncertainties that is related to the varying yields. Then there is a disaster. Then there is a disparity in the economic conditions, understanding, management, policies, price and marketing. So all this makes the agriculture is one of the very important the domain where new technologies are required. Definitely the spatial technologies through the Earth observation systems, it provides the important opportunity. That's a spectral, spatial and the temporal. These different the components, dimensions of the Earth observation systems are very much useful to address these issues. So we have the GIS technologies that has emerged, which integrates, visualize and analyze the aspects related to this. Then location and mobile mapping is also the important aspect through GNSS technologies. It's useful. All these put together, what it implies is that various applications of agriculture we may meet. It's possible to get the informed decision with making informed decision making with the knowledge. So just to give you the strength, primarily remote sensing, it would help. In a nutshell, I would like to say that to sustain, strengthen and advance and enrich the knowledge of agriculture. The most important aspect why remote sensing is most important is there is a very high spatial variability, so which could be captured using the space technology. We have the various sensors. We saw in the morning that there is a synthetic aperture radars, then there is optical sensors, then the meteorological sensors, which could be used to derive the target information, the target environment, soil, moisture, water, rainfall. All these aspects could be derived in some way. When it's coupled with the crop information, the ground information, the actual in situ information, then the past data put together from the ground and the space segment put together could be inferred, interpreted together with the techniques and the models could be used for the crop monitoring. I do not want to go much details into that because I am sure many of you may be aware, you could have read. So generally remote sensing, it uses optical, SAR, thermal, and even the LiDAR related sensors. Different the parts of the electromagnetic spectrum are used. So the leaves are sensitive to the leaf contains different components like the chlorophyll, the inside aerospace, the thickness, its orientation. So many components put together are present in a plant, and these it leads to different kinds of signature by virtue of the chlorophyll, which absorbs this the radiation, the red part, and the near infrared part it reflects. Then there is a water absorption components which is at 1.4, 1.9 and 2.4. So these the water absorption, chlorophyll absorption, near infrared reflection, all these things it together it results in the composite reflectance at different parts of the spectrum, which would we can infer about the leaf pigments, structure, water content or the background. All these components put together, we will get the composite signature. So this composite signature is a function of multiple factors, as I mentioned. At the end, based on this, we would be able to infer about the target and its condition. You can see that the different crops provides a different signature. Not only that, different crops, it shows a different pattern. So based on which we can assign that to a particular crop in an unknown area. Within a crop also, if you see, it shows at different stages of the crop. You can see the varying parts of the spectrum in the red, NIR, and the other parts of the region. So we can not only we can discriminate the crops, we can discriminate the stage of the crop and the type of the crop. With that short introduction about the crop signature, I'll just move to the how the remote sensing image looks. Primarily, I'll be touching upon the various aspects, the type of the application we have followed up. So before we move, Just you can see that what you see the left side, in the green color is the natural composite of the satellite image. An image, it will have the multiple bands. So generally that is we can use any number of the bands or the images for doing the classification. However, for visualization, we can see the RGB, red, green, and the blue. So these we can see the natural composite or the part of the spectrum which cannot be seen by the eyes could be artificially assigned to a particular band and could be seen as a different composite. You can see at the left side, what you can see is every minute details could be seen. You can see how the orchards are there. See different trees of the this one. You can see that a very grainy type of structure. You can also see the fallow lands. The fallow lands with little moisture could be seen in this part of the spectrum. So like that, every component could be inferred. Normally what we do is the near infrared part of the region which could not be seen in the eyes, we assign into a red part and see that as a false color composite. So the green, red and NIR, they are assigned into RGB, red, green and blue, and we can see the false color composite. When the field like this in the background is imaged during the satellite, you would be able to see an FCC like this or a natural natural color composite. So you can see that this part shows the different color variations, or what we call that as the signature. Signature is a definite the part of the electromagnetic spectrum which are well averaged over a part of the pixel. You can see wheat, maize, onion, cotton, vegetable. How do I know this? Because first we visit these fields and mark it as a particular crop. And based on the statistics, so these crops, it could be assigned to other parts of the unknown region to a particular crop. So this just to give how we can infer. Inferring depends on the statistics, it depends on the other aspects related to the texture, structure, association, then many other aspects are there. Primarily, we have various resolutions, and why we use the satellite data in agriculture, because it's a multidimensional. You will have the many frequencies, many aspects of it could be captured. You can get the structural components depending on the type of the sensor that we use. If we use the SAR data, we can get the structural components. It's repeatable. You can see across the time domain what is a change that is taking place. So you have the various type of satellites which are from the low Earth orbit, or from the geostationary, or from the other type of orbits. So you will have various types. You can just see in a temporal resolution diurnally how the things are changing. If you would like to see how the changes are happening over the season, you can see these regions where a lot of crop is there in the January, and slowly it reduces, and by May entire the crop is harvested. So you can capture the seasonal change. Similarly, annually also in the same year at the same time, if you compare, you can see how much area was there at one time and how it has decreased or increased. And over a long period of time, when you see, you can see how the reservoir was not there in 1972, whereas in 2002 it came out. Now there are different the dimensions of the sensors, which the spatial resolutions, what has been already it has been explained in the morning. So for a large area, we can use the satellite which is having the wide swath, so large area could be covered. When we have a better resolution, that is the better IFOV, or the pixels, say about say 24 meters or so, you can the swath becomes short, but you would be able to see more details. Similarly, when it's much finer, like say about 6 meters, you are able to see almost every field and the field minute detail. So depending on the requirement, when you would like to have a very large area assessment in a short span, you can use a coarser resolution, or when you would like to have very detailed information at the village level, or the sub-village level, or group of farmers, or some large fields, you can use a shorter resolution. Now, that is just to give the background. Now, let me come back quickly to the thing. Agriculture is very dynamic because there is a crop is there on the field, it grows. And the growth is a function of the many factors, soil, rainfall, temperature, etc. So anytime there could be the pests and disease incidences, and it can affect the crop. So we require the information throughout the crop. In fact, we require the information even much before the crop is sown, whether crop can be sown, whether the rainfall is going to be good. So this kind of information, all these it requires. One is the real-time data. Second thing is what was the past data. Second thing is what are the conditions today that would affect the next few days, or what could be the conditions that would be there in the future that would affect the crop, so that what kind of precautions or planning could be done. So we require, so hence what we require is information about the weather, soil moisture, the rainfall, all these aspects. Now currently we have almost data for addressing most of these issues. You can see that even before the crop is sown, IMD, that is a meteorological department in India, or some other meteorological resources, they provide the information whether it's going to be a drought or there is going to be lesser rainfall or more rainfall. So if you are a paddy grower, if you feel that rainfall is going to be less, then based on that you can plan to grow a non-paddy crop, or something like a maize or jowar that requires less water. Even after the crop is harvested, you can plan at the time of the harvest, etc., what is the expected production and how it is likely in the other regions, so that what kind of the pricing policies, marketing could be carried out. It is applied in the various domains. I just put in the various that is related to the area estimation, the production forecast, then the drought assessment, then the horticulture crop area, then the pests and diseases, then the soil, problematic soils, etc., then the command areas, water requirement, then the land monitoring, cropping systems analysis, then the crop insurance, then of course the fisheries is also part of the agriculture generally, which is a consider. So that is also, it is used. I will not be touching on that, just I have put it. Then also to make the global assessment, there are many programs that would make the assessment. So all these put together, it provides the whole domain of the agricultural information. So this, since our information would be available in the spatial form, a fertilizer market firm would look into the areas where the crop is more and where it would likely to come up. So he can plan the movement of the trucks, movement of the fertilizer to that region and priority, and so that there will be minimum inventory and the maximum use and timely requirement. Similarly, the Agriculture Ministry would like to have the information in advance so that it can plan the procurement and the storage. And the pesticide and disease, the industries, they would like to see where they would like to send the needy regions. So wherever the soil problems, etc., are addressed, they would like to see how best they can address this. Now let me just come back to the two key aspects, that is the area estimation and the production estimation. Generally, before we make the area estimation, we would like to see what type of the crop we would like to analyze and make the estimate, because all these techniques are crop dependent. See, I would like to tell, in India itself, we have about 252 crops grown, and Agriculture Ministry gives about estimate for about 52 crops, and 24 crops they give the pre-harvest estimate. So each of these crops, it varies in some way or the other. So it will have our basic, the principle is that the crop should have a unique signature, then we can discriminate it or identify it. Otherwise, we have to identify the way how we can bring that information to this. So choosing the type of the data, the crop, and the bio window. Bio window is the time, unique time at which you will get the unique signature. So at that time, data should be acquired. So crop, we can use different types of techniques are available using single date or multi-date. We can use the phenology-based analysis. We can also see what type of data set should be used, what the information we would like to generate it, whether it's the area alone, it should be in the form of map, it is the crop stage, etc. Then what kind of sampling, we may use a single date, and come out with the analysis, or we can use multi-date and make the analysis. It is the user dependent, it's accuracy dependent, it's a complexity of analysis in a particular region. So these are the factors that would derive. And maybe in the same crop, we would like to have the different types of the condition, different stage, etc. Then what's the time and frequency that are required? So generally what is done is the area estimation is carried out using single date or multi-date. Within that, one can use a sample-based analysis or the complete enumeration. The sample-based entire area is divided into different types of the strata. So each strata will be uniform, and but there is a minimum heterogeneity within the strata and maximum heterogeneity between the strata. So sample size of 5 into 5 kilometer or 10 to 10 kilometer and maybe about 10% or 20% is chosen. And only these regions are analyzed and make the estimation is made to the entire area. There's a sample-based estimation that is for the area. Or if that is not followed, then the entire the administrative boundary is overlaid, the classification is done, area is extracted, and then the area enumeration-based approach is followed. So once a area comes, then there is a area multiplied by the yield. It gives a production yield. We may have many options. We'll just come back to that. So in a sample-based estimation, as I said, sampling plan is prepared. The segments extraction is carried out. So each of them, it is about 5 into 5 kilometer. Within that, you will find that there is a wheat crop here, and there is a mustard crop here. So these are the areas which are inferred by visiting the field, that is called as a ground truth or a ground check. So these are given in the form of a polygon to the computer. Computer identifies, it computes its statistics, the covariance, etc. Then it is put in a logic. It may be multi-dimensional or the probability based. Different types of decision rules could be made. You can see the two-dimensional scatter plot. This is for visualization, but in a it has been converted into the weighting, and the distances are calculated with respect to the mean, and based on the distances they are assigned into a particular class. So these classes are classified the classified pixels. So you will see the down, what you are seeing is a satellite image, down is a particular classified image. You are able to see that is wheat, mustard, gram, etc. in different colors. So you will see by the area of every pixel, the pixel and multiply that by the total number of pixels, that gives the area. But when we would like to do the multi-date analysis, now that we have the large number of data sets available at the frequent time, one can see that these dates are co-registered, and this co-registered set is put into a decision algorithm. You can see that there are 3 crops growing on the same field, and when it is plotted as a function of time, you will find that one crop, that's a potato, is coming picking at a different time compared to the mustard, where mustard is peaking little earlier and coming down later. So a single pixel could be traced as a function of time, and this is built into the algorithm and classified into different crops. See, this technique becomes very important because there are many crops grown on the same region to different degrees. So there, the growth, it varies. The growth could be better captured. Just I would like to show that in the same, in 2 regions, Madhya Pradesh and Maharashtra, when the same crops are sown, you will find, see there, the peak of their growth or the greenness is different, it's varying, and their timing is varying. So based on this, you can assign 2 different classes. This is how it looks like. The total in Haryana, if you see, this is how the FCC is there, and this is how the classified image looks in a boundary approach. Whereas in a sample segment, you will find each of them selected samples and the corresponding classifiers. That is with optical data, but in a cloud condition, you are not able to get any image because optical data, it will not penetrate through the cloud, whereas SAR data does, synthetic aperture radar, but it will have only one band or one frequency. So you acquire that images over a period of time throughout the crop season, make the false color composite, and see the function of that as a function of the growth. The backscatter, what is called as a SAR backscatter, as a function of the crop growth, if you see, you will find it follows a different patterns. This is very much useful for crop like paddy, where you will find that whenever let in the water for transplanting, the backscatter reduces the least. And as it rises, as the crop grows, the backscatter rises. So this characteristic growth is used for discriminating the rice crop. So this is most commonly used method for the rice crop assessment. Once we have the area, we multiply with the yield. Yield, I'll go back, in the next set of slides. But then what we generally do is how there are different sets of procedures in between to check whether the classification is sufficient, they are separable, these aspects are checked. At the end, we have to check the accuracy of the estimation. So generally, when we use the sampling method, we use the precision and biasness. Precision means how good is your methodology upon repeating the same methodology, if it is followed in different regions by different people, how it could be reproduced. So your methodology should be precise. That's what the precision is. It should have a higher precision. Then biasness means when you are whatever the output that comes should be compared with the actual ground information. So which is called as the truth or the real information. So when it is compared, how much it deviates, that is called the relative deviation. The deviation should be as minimum as possible. Generally, when two estimates are made from similar procedures, then the estimations are close by. So this is another. So it should have a high precision and a low biasness. So generally, for the remote sensing, they use accuracies, mapping accuracies, user accuracy, producer accuracy, and the kappa coefficient is the integrated one. These are the general accuracies. Now, there are some global programs which are used. The Indian program is called as a FASL, Forecasting Agriculture Output, Space Agrometeorology, Land-Based Observation. In this case, as you can see from this figure, usually conventional method, they use the statistical methods and the field visits, and also use the meteorological information. Whereas in the remote sensing, that is, we can use a satellite image when the crop is seen on the field above a certain threshold, we can make the estimate. Now, India has made this kind of a program, what is called as a FASL, in which right from the pre-season to the final stage, all techniques are used. That is the ground observation, the meteorological information, the field observation, remote sensing, and other ancillary information are used together to make a continuous observation. This provides a multiple pre-harvest production estimation, and it uses most of the field as well as the satellite data. It uses the existing machineries of agriculture department for the field data collection through the mobile apps. Multiple forecasts are given for many of the crops. Now it's about 9 crops. It's going to increase to many more crops. So this kind of approach, it provides very quick information. In fact, I wanted to stress that the very strength of remote sensing is the pre-harvest information. Otherwise, other mechanisms also you can get the information, but it will be taking too much time. At least about 45 days in advance of the harvest, you will have the crop information. This is very, very, very useful information. So there are other global programs. LASSI is the one that started very early. Then there is AgriStar in the USA. China is having the Crop Watch, and that's the FAO is having GIEWS. Then there is a FuseNet is there by USAID. Then the European Commission uses the Mars. Then there is a GeoGlam, which is a GeoGlam program is of the Geo, which you will have more lectures from this. Now coming to the crop yield modeling, there are many aspects are there. So primarily we can have the statistical models, meteorological models, satellite input based models. Then there is a simulation models, then semi-empirical models. Many options are available. Now in a statistical model, you use the statistical data with the rainfall, etc., or the past data, and you will make a regression based, the models could be used. Normally it so happens that there's some meteorological factors will be influencing the yield. So these factors are made into a regression model, multiple linear regressions are used, and the yield is computed. In a satellite index-based use, satellite data generate the VIs, the vegetation index, NDVI, or so many indices are there. If it is a broadband or a narrowband hyperspectral indices are there, these are used to make the relationship with the actual yield. Or you can combine the spectrological and meteorological yield models in the empirical models. That is also possible. There are many satellite-based parameters are available. Why satellite becomes important in the yield model is that others are point-based or two coarse grade. In the satellite, you can get the weather information, soil map, then the crop area, then the crop phenology, then the leaf area index. All these different parameters, many of them would be in the spatial form. So you can make the spatial yield map as you are able to see that. So the method of doing this is maybe through different approaches. You see that in the spatial yield models, when it is made, you can see the variability in the Punjab, which shows a very high yield, to the Rajasthan, which shows a very low yield. So this kind of high variability is seen. So the yield models could be compared with the crop cutting experiments. So there are different models are there. One is spectrometeorological, as I mentioned, then the phenology based, then the light use efficiency model, then DSAT crop models. You will also have some exposure on these during the practical session that will be carried out tomorrow. So these for different crops, different types of models are used because the yield is a function of many factors, and the cereal crops will be highly related to the biomass, whereas the crops like the cotton, etc., they are not directly related at all the time. So we have to identify and bring out those parameters that would affect this. So these are built into simulation models or semi-empirical models. See, another the most common used is a growth profile. Profile means the growth of a crop as a function of time. You can see that crop, it emerges, then it grows, then it comes down. So the peak at which it, the maximum point coincides with the peak emergence, and the area under this curve, it shows the green biomass. And when the dry biomass is that's integrated, we get this. So this curve is synonymous with the green biomass. The rise and the fall, it also shows the rate of growth of the crop. So these, the phenology characters, it forms very important. When you capture the same thing using the satellite data, and this could be used in the model, you can see that in case of cotton, the peak value, the amplitude, length of the season, etc., these have been put and made into a function of the cotton yield model. So there are many aspects are there. Even the light use efficiency models are there, which the deterministic Monteith approach is used, where different parameters like the FER, APAR, and harvest index, these are used in the model. A lot of literature is available. I will not be searching much into these aspects. I would like to tell that many of these aspects now are available as a product. As morning it has been told by Dr. Dadwal that these products are available. One has to use these in their the models and decision making. That is with optical data. If you have the SAR data, in that case we have the rice crop. In the rice crop, we can get the biomass, because using the backscatter we can derive both the biomass as well as the transplantation date. These two could be derived. So we can use the biomass, and biomass as a function of the crop growth. A part of it, it will be used for the yield. And based on the simple, some of the modeling aspects, we can see how the biomass and the yield are related. This kind of approach has also been used. In fact, in the early stages, biomass is used as in the early yield estimate. Then later on, biomass, rainfall, and the controlling factors are put together, and towards the end of the crop, the integrated models could be generated. I'll just come to the two important aspects. One is related to the drought. The drought, you know that we have different types of drought, and most important is the agriculture drought, where the reduced soil moisture is there. So because of the drought, the crop may have different degrees of failure. It's very complex, and it cannot be attributed to a single reason. But however, it is slow and developing. So we require the short-term as well as the long-term management of this. In the long term, we have to develop those regions which are vulnerable and which are the risk areas, and we should have a long-term plan for how to have the diverse application management for this. Of course, in the short term, it's assessment. Drought becomes important because the farmers, whatever investment he has made, he will lose it. So he has to be compensated. So the government and the all the people stakeholders, they're ready to they would like to offset these loss that he would like to incur. See how it could be done. One is in the beginning there are many ways of approaching it, but of late now with the satellite data, you can directly make an assessment out of the crop condition, means how healthy the crop is. That is the one part. Second thing is you can also get the inputs from the rainfall data. Then there is a soil moisture, the sensors are available using satellite data also we can get it. Then the rainfall, hydrological, the input, primarily the reservoir levels, etc. This is another input. Then the area itself may be low. So to do this, what the government did is, the government, it looked into a lot of integrated things, and they came out with two aspects. One is, first thing is, it should be made into a very systematic approach. Trigger one is where the rainfall, if it falls, then only those regions should be checked. If the rainfall fails, then we should look into the second aspect, that is the trigger 2. That's how the impact indicators. It may be the reduction in the area, reduction in the remote sensing, the indices. Then there is a water availability, reduction in the soil moisture, hydrology, etc. And these should be checked with the ground truth. So based on this, the state government, etc., they can take action, and the farmer could be compensated for the losses. Using the SAR data also, we can get the backscatter also indicates whether the drought could be captured. The SAR image also, it will be of help, especially for the crops like rice, where there is a decrease in the backscatter, or the variation in the backscatter would show the variation in the soil moisture. Whenever there is a damage, crop damage is there due to cyclone and floods, so we can see that all these black regions are the regions in the part of the Orissa when there is the cyclone, the water was inundated, and these regions, we can see it in the post-cyclone region, these yellow ones are the ones where the crop was affected. That's a rice crop. In the other regions, it was not affected. So this kind of the assessment of the crop damage, we can do that using the satellite data, especially SAR data is very much useful. Then once a damage takes place, in the later stage, using the optical data, we can see to what extent the NDVI has varied. Accordingly, the extent of the damage could be inferred. There are other aspects related to pests and diseases. You can see that the pest and disease of a crop is a function of many factors. Primarily, it's the cloudiness, rainfall, temperature, and its intersection, it leads to development of the pest, say for a pest or a disease. For example, in this case, the wheat rust, it develops at a certain range of the temperature and the rainfall. So humidity, for example, if the temperature is between 10 to 15 degrees and relative humidity is more than 80 degrees, 80%, then the disease is likely to occur, provided the sufficient number of the spores are there. So these inputs related to rainfall and humidity, etc., these could be obtained from the meteorological satellites overlaid with the satellite images, and we can classify the wheat crop. And if you verify from the ground truth whether the infestation is there, spores are there, which are economical spores, number of minimum spores per unit area, then we can say that it's likely to occur. This is one such example. There are many other cases like AFID, the forecast using that, etc. The ISRO in Space Application Center, they have carried out the aspects related to that. Similarly, now it's also the locust surveillance. You know that the locust is again, it's a very dangerous situation where the locusts would come and destroy the whole field. So their infestation depends on their fecundity, the timing, the egg, soil moisture, etc. So many conditions are put together in a spatial scale, analyzed, and it has been assessed. Dipanvit, I have another about 5 minutes time. Hello?
Yeah, sir. Yeah.
How much time I have further?
Sir, you can continue for 10-15 minutes, no issues.
Thank you.
10 minutes, sir, you have 10 minutes.
Okay. Because I have been slightly rushing, that's why. So then let us now come to the another important aspect, the crop insurance. See, finally, the farmer has to get the returns to the crop that he sows. So the insurance is the important sector. Insurance is having multi-dimensions. So when the crop is sown, first thing is the farmers, many times the insurance is addressed in a different ways. In the countries like India, where agriculture is a state subject, many places are there where there may not be policy for agriculture. In some countries, there is a specific policy that they will tell in advance a farmer should not grow, and he would be given some amount as a minimum support for not growing. In some places, the farmers, they will grow, but they come across the damages. These damages could be due to many reasons. So it could be the weather related, it could be pest disease related, it could be calamities related to the hailstorm, etc. So in India, for example, if we put, there is a very mega program which is floated by the government of India, which is called as the Prime Minister's Fasal Bima Yojana, which is a government of India crop insurance scheme. In this, till now, farmers, they were not ready to become part of this scheme. They were not much aware, and there was apprehensions. Now that the government has given a very low premium, in many countries, the premium itself is set using the satellite data inputs. So rate of premium is also part of the insurance, which is decided by the company. So using some of the satellite inputs. In India, I just would like to tell that the government, what it has done is, it compensates the farmer to a certain extent. And there are many ways of looking at it. What they do is actuarial yield. If the yield reduces below a threshold within an area, then those farmers will get the insurance. Or if the weather fails beyond certain level, so then they would be compensated. Or if there is certain calamities which is being put, about some 9 calamities have been identified, 7 calamities have been identified. These calamities occur, they do give the compensation. For this, many things have been used. It's mobile-based applications and many assessment, but especially remote sensing has been identified as one of the aspects that whenever there is a discrepancy, remote sensing should be used to confirm. One is with respect to the decrease in the area, then with respect to the decrease in the average yield. Average yield over a period of time is a normal yield is taken, and if it reduces below that threshold, then the farmers, all those farmers in that area could be a small unit of conglomeration of the farmers, which is called as a Gram Panchayat or a village, group of villages. If it goes below certain threshold, they would be given. So in this, if the crop area reduces or area discrepancy is there, or prevented sowing, means in the beginning itself it is so low that enough area may not be coming. So these are all the ones which could be inferred directly and comparatively with a reasonable accuracy and with the minimum resources, with a minimum manpower in a shorted span. So this is one of the key strength of the remote sensing, which is having the direct application to the farmers. So natural, the loss due to natural calamities, etc. How it is done? Generally, it is done in a different ways. That is, they carry out the crop cutting experiment. They will actually go to the field, a known area of say 5 by 5 meters or different diamonds are cut, and its actual yield is measured, and based on that actual yield, they will see what is its variation with respect to the average, yearly average, and they come out. So to do this, how many numbers should be conducted, where how many crop cutting should be conducted, where they have to go, etc. These the inputs for these would primarily come from the remote sensing. In fact, India has taken a lead in some of these with the drought, crop insurance, etc., where the remote sensing scientists, agriculture, the experts, and the policy makers, they sit together. They have discussed, they have come out along with the policy makers on what should be the guidance and what should be the guidelines that should be followed for carrying out these aspects. Some other 2-3 points I would like to quickly touch in about 2-3 minutes. One is crop intensification. You know that in some areas, area may be underutilized. In these places, what they do is, if the rice crop is grown, it uses a lot of water. After crop is harvested, still soil will be wet, but many people might not grow. So in such cases, the areas like that have been identified where a short duration pulse crop or even a fodder crops, etc., could be grown. So these regions are assessed. Area is identified, soil moisture is how much is there, it's found out, how much is having the potential, and these people would be given the schemes and subsidies to grow a pulse crop. So this increases the area under the crop, it improves the soil fertility, it also brings additional economics to the farmers, additional income to the farmers. So these are some of the examples which I am just touching upon. Precision farming is another area. Not much has been done in the case of precision farming, especially in the countries where the holdings are too small. However, precision farming is having the scope in other places because primarily they use other sensors linked with the remote sensing and the communication satellite, and integrating in an integrated way they use for improving the yield or reducing the investment or inputs. So this is yet to take off, but definitely this is with more number of satellite sensors, more high resolution data, more frequent data, this will be becoming reality. Hyperspectral application is another domain, hyperspectral and thermal. In a hyperspectral, it is used primarily for the getting the different parameters of the crops. This also it will be useful for the precision farming and also for the quality assessment. Since it gives a large number of for this one, it is having operational techniques are yet to come up. However, we can discriminate the different the varieties, different the crop stages, etc. Also, we can derive some of the crop biophysical parameters. You can see that using the Everest NG data, this crop biophysical parameters are too many. Many are there. For example, to tell about the leaf area index, the date of sowing, then about the peak growth, then about the FA PAR. So many parameters are there. Some of them are derived. One example here is the leaf area index, that there are many algorithms are there. In this case, it is the using the Everest NG data, the LEI has been derived. So there is such a LEI of this type, it will be useful for using in the yield models. Similarly, leaf chlorophyll content is derived using the canopy radiative transfer model, which is the function of many aspects, including leaf, optical, soil, and the plant architecture, etc. So this is one aspect. Another aspect is deriving the crop stage and a very specific stage. For example, the scatterometer, Ku-band scatterometer has been used where the rice crop phenology has been detected, and whenever there is a grain stage it happens, that it coincides with the lowest backscatter. So this way we can identify the rice transplantation as well as the rice heading stage, which would be useful for deriving the yield. Horticulture, there are many applications are there. Horticulture, orchard seeds, we can use a high resolution data, we can use object-based, the classification techniques, we can use the fuse products and come out with the orchard map. Once orchard map is done, it's one, we have to orchards, it will remain for long period. So once in about 5 years or so, we can have the orchard, we'll have the inventory. And using this inventory, we can yearly, we can look at the conditions, and we can also use it in some way for getting the yield. Horticulture is, it includes varieties, that is right from trees. You will have the trees, you will have the bush, you will have the annual, seasonal, and even a very short duration crops. If you look at the condiments, etc., their varieties are there. So one approach, one classification will not hold good. So depending on each type, one has to look into various aspects. Most important with horticulture is its perishability. So there are 2-3 dimensions of the horticulture. It could be addressed using the remote sensing and GIS techniques. One is the site suitability, where all we can expand this area depending on the conditions. It may be slope, aspects, moisture, direction of sunlight, etc. Using this, putting into a GIS layer, we can see which are the areas. Similarly, post-harvest infrastructure, say for example, potato, the regions where it grows, what should be the minimum route, where the current cold storage are there, what are its capacity, and if it is a surplus, whether we can enhance the capacity or build new infrastructure for the cold storage, etc. This kind of the post-harvest management, and also the intensification. See, wherever we can, which are the regions where after growing the crop, whether vegetable could be grown, then the old orchards identifying. These are some of the aspects which are generally addressed. In fact, these orchards means actually well managed with the proper spacing, etc. One can look at the high resolution image like this. So at the Space Application Center, they have developed the algorithm where one can count the actual number of orchards automatically. So this kind of the techniques, it also adds new dimensions in the remote sensing in GIS. 1 or 2 aspects I just would like to tell about the sustainable development. Using this kind of spatial information, we can generate the seasonal cropped area or the cropping pattern. You can see here in the Kharif, the rice, the crop is mostly distributed here. In the Rabi season, you will get the potato, mustard, wheat, pulse crops. Then in the March, again in the summer season, you are going to have the rice crop. If you overlay all these one over the other, you will get this kind of map, which is called as the crop rotation map. The same pixel is used for cropping. How many times is a crop rotation? A sequential growth of the crops. You will find that all these green areas, there is a single cropping season. Yellow areas means the 1 season crop, 2nd season is not there, 3rd season it is there, and there are some regions where there are 3 season crops are there. So obviously you can infer a lot of things from this. These are the regions where the people are the single cropped area, social, the economy may not be that good, whereas these regions must be better off, well developed, and this kind of information you could derive single cropped area, double cropped area, triple cropped areas. Based on this, you can get how many you can compute the indices related to how the land is utilized, what is the diversity, etc. If you would like to extend this, grow more crops, then obvious reasons are these regions where there is a single crop is grown. But how you will be able to do that? You have to use a geomorphology, groundwater, then soil, then the rainfall, all these things put together, you will find the regions where there is a scope exists for increasing this. This is a vertical expansion. When you cannot expand horizontally, then vertical expansion is the other option. So similarly, when the crops, you can see that in the 88, 89, see their wheats and other crops are grown, but at a later stage, you will find that other crops are not growing, only the wheat is grown. So that means diversity has reduced. In these regions, we have to increase the diversity because it's required overall for the sustainable growth. Apart from the cropping system, there is what is called as a farming system where not just the crops, but many enterprises, it may be piggery, poultry, livestock, etc. All these should be used because the farmer is a user as well as he is the best economist also. So we have to see how best multiple enterprises could be used. Again, remote sensing and GIS comes in a way into that. As I'm coming to the last 1 or 2 slides, that is agro-environmental, you will have the impact, means the environment in which the agriculture is being carried out, it will have some impact depending on the type of the crop, the management, etc. Suppose the paddy, you know that the paddy crop, it results in the emission of the methane. So the more the paddy crop is grown, you will find that the more methane is emitted. So these are the regions where more methane is emitted because crop is grown more than once, so multiple seasons, and added to that there is a more irrigation. So crop stands under irrigated condition for a longer period. So this gives an idea about how to compute how much methane is emitted from the rice crop in the entire country. Such kind of inputs are important for the communicating to the international community and also to see how the mitigation could be carried out. And if you see which part of the year it emits more, you will find that in the January, February it will be low, but August, September, there is a higher emission which coincides with that. So not only the methane here, but also the non-point source pollution, like how much the urea leaching takes place, ammonia volatilization takes place, these are also forms the part of that. Of course, climate change is going to happen, but if it happens, what will be its impact on the agriculture is one of the common questions that we see. So using the projected climate in the 50s and 80s, when it was studied, we found that there's going to be decrease in the yield. And this is in part of the Punjab of India, where we find that there is going to be yield decrease from 5 to 50%. Then what we can do? Obviously, we should have the mitigation strategy or how best we can adapt yourself, either through the varieties, etc. But for that also through the simulation models and the meteorological models with the remote sensing inputs, if we do, we find that we can partly by adjusting the sowing date, delaying it, that will meet the suitable temperature and rainfall needs, we can partially offset, 10 to 15% could be offset at least to the extent. So global monitoring I mentioned. So using the satellite data, I mentioned about the global programs where the different countries, they come out with the various the inputs related to the country-wise the estimations of the rice, wheat, soybean, etc. major crops, because that will decide for the aids, the production, economics, then the import, export, etc. So using this data with the multiple dates, we can derive the different crop calendars at the global level. Then we can also derive the important inputs that are required for the greenhouse gases emission, like the rice cultural types, rice calendar, etc. So many things are doable. Now the applications are at a very advanced stage. You can see that when these inputs, historical inputs are put together, the past temperature, meteorological, rainfall data, and the historical remote sensing data, you can just see on a web-based, web GIS-based vegetation monitoring that is developed at the Space Application Center and the Vedas portal. You can see that you just click on the point, you will see how was the profile of a particular crop over the years. And as of now, you can see that the point is at this stage. So what pattern it has followed, that you can get it over a period of time. This kind of the web-based vegetation monitoring and tools analysis is becoming very popular. Now I'll just come to the last part of it. I have just brushed through the presentations. So generally there is an emerging trend is that there is an increment in the spatial, spectral, temporal resolutions and hyperspectral sensors coming out. Of course, thermal will be added, and the two high resolution thermal as well as the stereo imaging is coming up. Microwave multi-frequency polarimetric data is available. In fact, I did not touch about the different multi-frequency, multi-polarimetric classifications, etc. But there is a lot of scope. Then there is satellites are agile and small satellites, and UAVs are adding on to this. There is in situ sensors are there, cloud source is there, cloud computing, morning we were discussing, that is there. Then synergy of the technologies, that artificial intelligence, IoT, communication, navigation. Then there's a technological revolution is taking place in IT. Then the ensemble model and fusion, different expert system are coming up, and a lot of startups and private sectors are they're all coming up with these. Of course, we would be able to do the crop estimation for many crops in a frequent, accurate, and at a wider scale. Loss assessment could be on a real-time basis to a comparative acceptable accuracies. Then crop planning is possible with extreme weather, pests and diseases for these conditions. Then value-added agro advisories and early warning systems would be doable. Then we can enhance the irrigation and water use and lead to the sustainable use of the land resources. Of course, it should all lead to the long-term database generation. That's all from my side. I thank the UNOSA, then Director Steve, Dr. Prakash, and my ISRO colleagues from SAC, NRSC, RRSs, State Agriculture Department, Remote Sensing Centers, Anand Agriculture University. Of course, Deepanvita is also there. We have worked together. So I thank all these people for giving this opportunity. I'm sorry that I did rush through. Maybe I had put a lot of inputs. Thank you very much. Thank you, Dr. Deepanvita.
Thank you, sir. Thank you for the detailed coverage of the topic, spanning from crop identification, yield modeling, crop assessment, insurance, intensification, precision farming, crop calendar, cultural types, diseases. Sir, you have covered all the applications of agriculture in a very detailed manner. So I hope the participants have gained a lot from this talk. Now we'll have few questions, sir. I would like ask the participants if you can type the questions in the chat box or you can raise your hand. We'll take few questions, sir. Sir, they are asking how groundwater affect the crop yield. How the groundwater affect the crop yield. Sir, Manjunath sir, they're asking how groundwater affect the crop yield.
Hello.
Sir, yeah, sir. Yeah.
Actually, I just missed it. I think I got logged out and I'm again in.
No issues, sir. Sir, we have few questions.
I have. One
how
is
the crop calendars be plotted on maps and what parameters are required, and also can it be done on local levels, the plotting part. So this is one question.
Okay. I'll take this the question. Generally, crop calendars, what is done is there are different ways of generating it. it should be how it could be plotted on the maps. What is done is there is the crop, when you have the multiple temporal data sets, that could be used to generate the profile. The profile, using the profile, that shows you can calculate, based on the parameter, you can derive the starting end of the that is end of the season, or the start of the season, or the max of the season. So any of these you can derive it, and you have to add the buffer data in the beginning. Then that could be same for every pixel. You have to assign this between the values, that is between if it is a paddy crop, say 0 to 120, like that. Based on this, you would be able to generate it. Maybe I think I would have shown in my PPT. That is, that way it is possible to generate a map. Primarily what parameters are required is it's nothing but that is a maximum growth is, if you are going to plot it, the peak period of the crop, or if you want in the beginning, in that case what you have to do, the threshold NDVI, that it should be taken up. So threshold NDVI, that usually it comes after about say about 10 to 15 days after the transplantation or so, or after sowing. In that case, you have to add to that threshold day on which you will get the threshold about 15 days. You have to subtract it, you have to go back, then plot. Okay, then
yes, sir. Another question is, sir, are there any open information about the local area which can be used by local farmers to increase their yield?
Now, the information on the area, local area, is as of now, it is not available on the in a public domain. Normally what is done is the area estimation, whatever is being carried out, area and the production is for the policymakers. So the inputs what they generate, normally that will be used by the policymakers for various their decision processes. So only when the complete area is made and it has been validated, then it would be put in the public. So local area, as of now, there is nobody is generating it. So that's one aspect, but definitely there is a scope. Lot of startups and private industries are there now with the new availability of the data, etc. That could be taken up.
Sir, another question on drought assessment. Are farmers given information about the possible crop based on satellite based ground drought assessment, especially in context of climate change?
In drought assessment is available to all the states, etc. The information, what happens is, once the drought is there, then the government, they will, as I mentioned about the failure of the rainfall is a trigger one, and the trigger two is related to the remote sensing index, then the reservoir water level, and other parameters. 3-4 parameters are there. Any of these three, if it is met after the rainfall failure, this information is given to the respective the state government, and it flows down the information through them up to the village level. So farmers, they would be getting it, the information.
Yes, sir. Another question is on locust movement, whether it can be traced by checking the soil moisture. Greater the soil moisture, more the chances. So can the kharif production after rice harvest be the way to avoid locust? Is it not that locust actually move to the places where kharif is planted, kharif rice is planted?
Actually, normally what happens is locust, it comes from, this is across the continent. In fact, from there are different regions are there. It's very interesting to study that their breeding, etc. is subjected to lot of this one. Primarily it comes from the Oman and those regions, then to Pakistan, then it comes to the northwestern part, primarily Rajasthan and these desert areas. It used to be restricted to only that place. Only in the last 2 years, we are finding that it is coming little deeper into the region, to the part of some part in part of MP, some part of the almost close to the UP side, etc. So this it's a Kharif rice is not the Kharif season. Primarily, it's in the winter, post-winter time. The timing, their breeding, it depends on many other the factors. So Kharif season is not the thing. Primarily, it is a winter summer period. It depends on their that is the time of their reproduction stage, etc.
Okay, sir. What parameters of groundwater indicates that crop yield is going to increase or decrease? The next question.
Yeah, groundwater. Primarily, what the parameters of the groundwater indicates. Actually, groundwater is primarily it is used for the irrigation. It's the not the parameter of the groundwater. We know that the groundwater table is going down. Normally, what happens? The farmers during the Kharif season, they don't give the they do not use a groundwater. Groundwater is used only when the rainfall fails to give during the critical irrigation only. But in the summer season or the late winter or the summer season, they use what parameter of groundwater indicates crop yield increase or decrease. That way, it is the primarily if the water is at a higher, the water table is high, they use it more frequently. And if it is at a lower level, then they use it at the thing. Basically, it's a yield, water yield. If the yield is more, then the yield is going to be if they are going to use it for the critical stages, then the yield is going to be more.
Thank you, sir. Thank you for the excellent talk and a very wide coverage. All the participants have definitely benefited a lot from this talk. Thank you so much, sir.
Thank you very much. Thank you very much to all the participants. Again, to the UNOSA for organizing this, and Steve for taking giving me the chance. And I thank Director Steve and all the organizers from IARS and UNOSA, and special thanks to you, Dr. Deepanvita. Thank you very much.
Thank you, sir. Thank you so much, sir. So, dear participants, we'll break for lunch and we'll reassemble at 5 minutes before 2, so that our next session, the hands-on session, will start at 2 p.m. Right? So let us break for lunch and we'll gather at 1:55. Yeah, so welcome back after lunch. Am I audible?
Yes, ma'am.
Okay. So we'll have the first hands-on exercise now on image interpretation and digital image processing. So this hands-on exercise will be mainly taken by Mr. Abhishek Danodia. He is a young scientist working as scientist engineer at IARS, and he has been awardee of JRF, SRF and many fellowships, also the ICR Net. He made substantial efforts to make significant advances in EU applications, which includes crop water requirement, ET, energy balance studies, crop inventory, crop yield forecasting, and drought assessment for achieving sustainable agriculture. Recently, significant contribution is made towards integrating space observation, scintillometry measurements, and surface energy balance models for assessment of water requirement over the terrestrial ecosystem and crop yield modeling under ISRO's Sufalam project. So this practical will be broadly taken by Mr. Abhishek. He will be covering all basic aspects of image interpretation and then digital image processing in detail. And towards the end, little bit on SAR image processing I'll take up, because we will be having more lectures and practicals in the next day, that is on 7th. So let us start now. Over to you, Abhishek.
Okay, thank you very much, ma'am. Once again, very good afternoon to all dear participants. I once again welcome for this specific training program, and now that demo session, which I just go through the part of image interpretation, then digital image classification and accuracy assessment part also, basically using the optical data sets. So first I just share my screen. I think my screen is visible to all of you.
Yes, actually, can you share only the presentation part or the demo part, because our screens are, yeah, now your desktop is visible.
Yes. It is okay now, hmm?
Yeah, it is okay. You can open your softwares or whatever. Desktop is visible, yes.
Okay, thank you, ma'am.
Yeah.
So first of all, regarding this our today's practical exercise or demonstration exercise, we just go through the part of digital image processing. First I will go through the part how we interpret the image which is acquired by various sensor. Like here I just go through the part of image of Resource-Set 2A satellite data, and which is acquired by LIS-3 sensor. LIS-3 is our Indian Remote Sensing Satellite sensor, which is line imaging self scanner. LIS-3 sensor, which has a spatial resolution of 23.5 meter. So in this regard, first of all, here as I go through this part of software, which is ADAS imaging. So how to use this particular ADAS imaging software, I just go through that part also, and further that, so unsupervised classification and supervised classification follow with accuracy assessment part. So very first, we have to open any image which we already saved in a specific folder. As I just make a separate folder for this particular exercise, and I choose the image which is acquired on 23rd of October 2015 from the LIS-3 sensor of Resource-Set 2A satellite data. So I just make it fit image to window, so you can visualize complete tile of the image, and also I make it in terms of band combination, because as we already have a knowledge regarding LIS-3 sensor, which has a 4 band, the bands are green, red, near infrared and short wave infrared band. So according to make a combination of that, we make a standard false color composite. So for that we have to choose the specific band of band 3 as R, band 2 is for green, and band one is as the B. So which a combination of RGB, red, green, blue, we make it as the same near infrared, red and green band. So as it is exact visible with this particular screen, as you can see. This is the scene of LISTRI sensor, which is acquired for an area of Dehradun Valley. We specifically choose the area of Dehradun Valley because that particular valley area has all possible kinds of land covers, land uses in the single tile or single image. So here you can easily visualize the various possible land covers as I discussed by one. So based on their color tone and their texture part, as well as the part of, you can say, tone variability, we can define various kind of land cover. Very first, if I start with the color of combination of like RGB. So very first the part of red color. So here the dark red color, which cover a significant area in the same tile. So how we can interpret the things might be my senior eminent speakers, they already briefed the part of spectral signature. So once again, I just brief you the same part. Like as we are talking about the typical spectral response curve, which is based on the spectral curve, which define a scatter plot between wavelength versus the reflectance value from the particular object. So if I simply classify our Earth surface broadly based on their, you can say, the land cover part, which may be the soil, which may be the agri, or which may be the water part. Or you can say the combination of all three classes. So here you can see based on the wavelength part, like it is mostly in the part of in nanometer, and which is covers our visible to NIR region, NIR to sphere region. So at the spectral signature curve defined from the visible range from 0.4 to 0.7, which is mostly a leaf pigment dominated area, or you can say there is a chlorophyll absorption band in 0.4 and 0.7 micrometer, with a follow with the near infrared region, which is dominated with the cell structure, or define the information regarding the cell structure as has a high reflectance vegetation in the near infrared region. So there is also a contrast between the NIR red band and NIR band reflectance value, as here it is around 0.1 or around 0.15, whereas in NIR it is more than 0.5. So there is, based on their difference between, or contrast between NIR and red band, various kind of spectral vegetation indices has generated also, as well as the same information with further follow for classification inputs. Okay, so based on the particular information, we further choose or further define how the particular image has different kind of length covers. Like as we convert the NIR band information into red band, so where is the red band defined, which is prominently from the or predominantly from the red band region or red band reflectance. So higher red band reflectance is always from the visible range, as I already discussed in the spectral signature curve. So where is the red band? It is the which define the dense vegetation part, and dense vegetation, it is the area of the forest area, the Sal antique forest area of the Dehradun Valley, which you can see in the dark red color. Along with, if I just go through the other kind of color tone like blue color, so there is a two different distinct feature in the same blue color. So one is the complete lined up of blue color, and another one is the unlined blue color area. So there is a distinct feature between it is the like river region, river bed area, or the river area or river pixel, while the lined up area is the canal area or the canal, concrete canal. So these two distinct features, based on their color and color tone basis also, we can visually interpret the type of particular class, or you can say land use. Then come to the cyan color. Cyan color also is prominent with around to the river side area, which define the river bed area. Now come to the another kind of red tone, which is lighter in terms of red, and which is moved from the slight pink to reddish in tone, and which define the agriculture or cropland area. Now one more thing in the same, if we compare the cyan color from the riverbed area and the same little bit similar to cyan color from the other kind of land covers, which is the similar because of the reflectance value are similar from the dry river bed area, this and this is the urban area. And why the reflectance value are similar from the urban area and the dry river bed area? Because of the similarity of the material or the constituent of the same both the land covers. Like our household or the urban structure are made of the concrete, cement and combination of water, which is the same or available at the dry river bed area. So that's why the color resemblance is same, or in terms of light cyan to dark cyan color in the satellite imagery when we convert into the false color composite part. So these are the all are broadly type of you can say based on visual interpretation we can define various kind of land covers or land uses in the satellite imagery. Now come to this particular software part. So very first, as I define you, just go to the raster option. In raster option we make a band combination, and using the band combination we can define or we can generate, make it as a standard false color composite. This is the very first part. Then second part is for this come to the information of the raster and the attribute layers. So attribute layers as it's defined from like that their total from 0 to 342 as a dry subset of particular area based on their histogram values and the area dominated. Now come to this the classification part. This is overall about the visual interpretation, how we interpret the image based on the structural signature part. Now come to this the classification. As I just go through or discuss in the demonstration part the unsupervised and supervised classification. So there is a very basic difference between unsupervised and supervised classification. Unsupervised classification simply classify the particular image based on the available DN value, or you can say digital number value of the satellite imagery of the acquired image. While the supervised classification is simply classify the image based on the training sample. So if I thoroughly define or more elaborately define the unsupervised classification, so the unsupervised classification is based on the software analysis of the image without the user provide sampling classes. So based on the arbitrary number of like 10, 15, 20, 40, based on the number of the classes as user defined, number of the classes is classified in the unsupervised classification. And the same software programming, you can say the computer uses the technologies to determine which pixels are related and groups them into the classes. So based on their values of in terms of clustering of the data sets of DN value, they make it in a cluster, and that cluster represents a particular kind of class. So the user must have knowledge of the particular area in the unsupervised classification when they grouping the pixel with a common practices produced by the particular software in the computer, and that to be related with actual feature on the ground. Like what kind of actual feature, like that maybe the forest area, wetland area, agriculture area, riverbed area, water pixel, water area. So based on that particular actual ground feature, that can be further classified. In contrast, if we just discuss the part of the supervised classification, so the supervised classification is represent or the specific classes, and then to direct the image of the processing software, like here as we are using the ADAS imaging software, and that should be through the particular training sites as the reference of the classification for all other pixel in the images. And we have to define the training sites, and these training sites are the selected based on the knowledge of the user as well as the ground based information, or you can say ground truth data sets. And nowadays, like you can say, there's some of the researcher or user, they are using unsupervised classification, some are using supervised classification, but nowadays various researcher or analysts, they use combination of the supervised and unsupervised classification, and that to provide a final output analysis in the classified image. Okay, now I just move to the part of the demonstration. The very first is the unsupervised classification. For the unsupervised classification, first I have to go to the particular, that is the same tab bar of the ADAS imaging 2018 version. Simply we go to the classifier. In classifier, the second option is the unsupervised classification. We have to click on that. A new pop-up window comes where we have to add up the input raster image, and that should be in .img. If the data set in the .tif image format or in other SDF format, we have to convert into a .img, which is suitable for the ADAS imaging software, and we have to add up the particular data set. So we have to select the particular folder, as I already add up this here. So I simply select the particular image which I already showed you, which is from 2015, 23rd of October. So I select this particular image. Then one more next in the same pop-up window. The next option is the output clusters layer. So what kind of clusters layer or the final output signature data sets we have to add upon with the final name as in .img format. So here I again select the particular folder. I just name it as unsupervised using that particular October image, and that is already there. And it shows in the files of the type, which is the imaging image or .img format. We have to click on OK. Now it's, you can say, we add up the input image, which is of 23rd of 2015, which is shown in the same viewer window, and unsupervised, which we have to name as an output classified name. Now come to the part of the method, which kind of method we are using for the unsupervised classification. So these are two types of methods. One is the k-mean, another is the isodata. So if I just go through the little bit detail of the isodata classification or isodata clustering, so the isodata clustering method simply use to the minimum spectral distance formula form cluster. So for the clustering purpose, that it does the particular isodata clustering method is used, and that begin with the either arbitrary clustering means or means of the existing signature data set, which is already set in the signature data. So each time when we go for the clustering repeats, the means of these clusters are shifted because of the data set type. Like the data set is 8-bit data sets, 10-bit data sets, 12-bit data sets. Based on the radiometric resolution of the data sets, that their clustering is changed on arbitrary method or arbitrary form. So the new cluster means are used for the next iteration accordingly. And if we just go through the difference between isodata and k-mean type of data sets, so there is a very distinct difference between isodata and k-mean method. Like isodata algorithm allow for different number of the clusters, while the k-mean assumes that the number of cluster is known a priori. So based on that, we have to select maybe like k-mean, or you can select the ISO data sets. So regarding the all sort of information, like how we execute this particular exercise, the same regarding manual part, we already have prepared it. We will share you the manual part also and the same data sets for your further practical execution on your side. And if you have further any query regarding this, you may contact with us on the same day or the next day also. Okay. So that regarding the part of manual and all sort, we will share with you very shortly by end of this my demonstration part. Now come to this method again, like k-mean method or isodata. We have to select number of the classes. How many number of classes? So by default it's mentioned like 36 classes. So we from that we just make it like 10 classes. Or so we know like there is around 7-8 classes are there in the same area. Like if I named all the predominant classes, forest area, forest pixel is there, urban area, river bed area, river area, dry river bed area, then settlement area or orchard area, agriculture cropland area, and fallow area. So based on this, like prominent 7-8 classes are there in the same area, then Dehradun Valley. So based on that, we simply like a normal arbitrary basis, because it's as in unsupervised classification we are doing based on arbitrary method, the clustering of the data sets. So we make it by default is it like 10 number of classes. Now come to the processing options. There are the two processing options are there. One is the maximum iteration. So maximum iteration is mentioned as 10. So 10 iteration, it means like when the software go for the unsupervised classification and it's classified, the total 0 like 8-bit data set is there based on the radiometric resolution of the data set, which is 8-bit data, and 8-bit data has res in terms of digital number from 0 to 255. So based on the value of 0 to in between 255, like make it like 10 classes. So 0 to 40, like make it one class. So the 0 to 40, 10 times make iteration, like where is the value is lies in between the same class, and according to this classify on particular type of class. So based on the, as we define the clustering part, clustering is done in terms of multiple time of iteration. Then conversion threshold, as we make it, the threshold is 0.95, which is by default, and we can choose the same thing as it is defined. So as we already mentioned, the input raster file, output raster file, k-min data method of the k-min, which and number of classes is 10. Now I just click on OK, and the processing list is shows where is the processor's title as defining. So iteration as doing in terms of 1, 2, 3, number of 10 iteration as it is formulating, and ultimately the exercise has been executed for unsupervised classification. Okay. Now I again open a new viewer window, a classic viewer. Here I just choose the folder very first where is the classified image is there. I select the particular image, go to the raster option and select here the pseudo color, because we have to further assign the color as per the color coding or color scheme in unsupervised classification. So we select the pseudo color and make it OK. Now this is the overall image which is classified based on the number of classes 10, method of the k-min with maximum iteration number of 10. So here now I just go to the part of raster. In raster, go to the part of attribute. So here you can see the all possible color which is available in the unsupervised classified map, and their name, like name is class 1, 2, 3 up to class 10. So based on this information on visual interpretation as well as a high resolution imagery or a already classified map of the same area, we can compare our result and we can make it a final classification output. Now how we can do the things based on the already available high resolution data sets. Like for the same area, I have one classified data set. I simply open the particular classified data set for your reference part. Okay. So now you can see this is the same area, almost same area which has different kind of classes, and we can compare the viewer number 3. The left one show the actual derived class earlier reference image, or you can say classified in output, whereas the right one image is in terms of pseudo color, which is we classified now using the unsupervised classification method. Now based on the color scheme, as we can define and we can recolor it and make it final as per the color scheme of various kind of land use land cover. So now come to this very first, if I just go through this histogram value of, or you can say row number 1 and histogram value of 27829 with a color of gray. So where it is possible area is there, we can zoom in this particular area. So it's as per the color scheme, we can see it's a area of water body. So we can color up this particular area according to the color scheme. So like I just make it as a blue color. So now you can see where is the possible water bodies are there. It's blue color. Again, it's make a mix up of with other class also, which may be like you say shadow effect in the forest area as well as the even the mountainous region shadow. So both the like forest shadow as well as the mountainous region shadow at the time of the satellite image acquisition, which is also also affect the acquired digital number value of satellite imagery. So that is a part of limitation when we are taken care about or when we are using the unsupervised classification. Now come to this other type of like as we define, it is based on like this is the forest area. So we make a classify it. It shows that classification as dense forest area. Again, we can, based on this particular, we can arbitrarily choose the data sets as well as the color scheme. Like it is a resemblance with the area of somehow here, which is the area of the plantation crop. So we make color a different color of our plantation crop, like we make it like little bit green color, which is nearby the, you can say, urban area, as well as the riverbed area, which is prominent defining the plantation crop or horticulture crop. So in the same fashion, we can color up all the image in the unsupervised classification one by one and define the classification input based on the particular type of data set. Like as I show you here, the dry riverbed area, which is make more resemblance with the urban area because of the same kind of reflectance value in image of in the class of urban as well as the dry riverbed area. So this is the, like when we select the only 10 class, so this is a little bit a part of selection of the less number of the classes, as well as the unsupervised classification where is maybe the shadow effect is there, or maybe you can say the mountainous region that solar radiation shadow in the at the time of the image acquisition, which is also make a limitation of final digital number value of the particular image. So like this when we select only the 10 classes, there is a much more, you can say, similar pixel are mixing with each other, which shows the limitation of the unsupervised classification. So for that, we have to do one more thing. We can select arbitrary, again I just mentioned it, we can select, again we have to go through the classifier in unsupervised, select the input image of 23rd of October 2015, as I mentioned is the unsupervised classification October. Now I again rename it as 1, and now I just make a class like 20. Earlier as we defined is the number of classes is 10, whereas it shows the limitation of different kind of classes in terms of forest area also, as well as the urban and the dry riverbed area. Now I just increase the number of classes by 10 more. Earlier we select the 10, now we make it the 20 and go for classification. So now the processing part, it is there, the iteration is 10 number of iteration is done, and ultimately classification output it shows here. So I remove this particular, I add the newer one classified image using unsupervised classification. Okay, and again go to the raster. In raster there is a option is attribute. Okay, so in attribute option there is number of classes, like as now we choose the 20 number of classes from this particular same image. So like this we can make a thresholding in terms of number of images as well as a particular kind of classes. As I already discussed with you, like nowadays researcher or analysts are using combination of supervised or unsupervised classification. How they are using unsupervised and supervised classification in make a combination form? They very first the prominent class, like prominent class of, like as we define the forest area, which is more or less is not much changes are there over the period or over the year. And the same, the water bodies also. Water bodies, like the river channel area, that like you can say maximum fixed area, or you can say the area or the particular kind of land class which is not changes over the period, over the time. So these particular classes they classify using the unsupervised classification. Rest of the classes they classify through supervised classification and make a mosaic of unsupervised or integration of supervised and unsupervised classification output. So that is that is a kind of hybrid approach, and in hybrid approach they are using both the unsupervised and supervised classification method. Okay, so like this you can select arbitrary one by one, increase the number of the classes in the unsupervised classification, and then define based on a higher resolution imagery or maybe already classified image of the particular area, or you can use the actual ground truth data set from the particular area and define like this is class is exact from the resemblance with actual ground condition. So based on that you can color up this particular image and define the class name also. Like here I just mentioned it is dark blue color which shows the water body, so I just rename as it's a river bed, river area, so I just make it class name is river. Okay, so like this you can change the color scheme also, rename the particular class based on their features or information from high resolution imagery or already classified imagery. So this is a very brief about the unsupervised classification. So now I just move to the supervised classification, and further I have to discuss the accuracy assessment part also. So first it is all about the unsupervised classification. So I just move to the next type of classification, which is supervised classification. As you can see this particular image in terms of FCC, false color composite image. Again you have to this classifier window. There is the option is signature editor. As I already discussed in the supervised classification, we have to define some training sites, or you can say we have to define some signature based on the exact ground based information, or you can say based on the ground truth data sets. So it is a in terms of flow of classification accuracy or classification part also, like based on the only a reflectance information or digital number information based on the radiometric data set of the satellite data, we simply go for the classification, unsupervised type of classification. Then we just go to the field using the GPS, you can say a reasonable or reliable accuracy defined GPS, and we get number of GT point, ground truth point from our study area or our desired location. And these information we can use in the defining training data sets. And these training data sets we have to incorporate in the signature editor and further go for supervised classification. So now I just move to the supervised classification. In the supervised classification, very first we have to define the signatures. So how we define signature? In the classification tab, very first option is the signature editor. Now signature editor tab is open. You can see here the various, you can say information in terms of various columns like signature name, color, what kind of colors are there, order, count, probability, all sort of information you will get in this particular signature editor when you select the particular kind of ground based informations. So for that, very first you have to add, as I already opened, the raster layer image in the viewer menu, and we already open up in terms of FCC, which is a color scheme of 3, 2, 1 from the band of NIR, R and green. So for that, very first we have to go to this same window of viewer window, where the fourth option is the AOI. AOI is the area of interest. We just click on that and select the tool option. So in the tool option, there is a number of tools are available, like which I go to one by one, which is select of the particular AOI elements. This is for the box select AOI. This is the create rectangle AOI. This is the rectangle, it's a create ellipse basis AOI. This is the polygon basis AOI. This is the line basis, polyline basis AOI. So all sort of, you can say AOI tools are there in AI, very first in AI tools format. So for that we have to choose this particular polygon type and further choose and insert in the signature editor based on the ground based information. Like for that I just choose this particular create polygon AOI. I simply zoom in this particular image and best possible to select the pure pixel of our study area or pure pixel of particular kind of class. Like here, as we can see, or if we zoom in the particular all the image, all corner of the image from north to south, east to west, we can see various kind of color tone and their variation within the particular image. Like this is the area of dense forest area. Within the dense forest area, this is some water channel lines are there, which may be the seasonal. Okay, and also based on their elevation, because of the elevation, there is also shadow effect is there on the other side, or you can say that on the northern side. So like this, based on all sort of the possible attributes or information, we have to select the pure pixel from the particular image when we select the polygon of AOI. So I have to, again I just select the AOI, zoom in this particular image, click. Sorry, little, I think some issue is there. Just a minute, just a moment. I just sort it out. So I again go to the viewer, select the viewer window. Now a new window will open. Here you can see it. I simply add up the particular image which we want to classify using the supervised classification. So I just select the image of the same image, 23rd of October 2015, acquired from using LIS3 sensor. Make it the raster. In the raster, we just go to the band combination. Again, make it as a combination of 3, 2, 1, as a combination of NIR band, red band and green band, and which shows it's in form of standard false color composite. Now go to the AOI, select the tool, and here the tool bar will open. I simply select his here the polygon type, zoom in this particular area, select a best possible pure pixel area for particular type of. Now the particular polygon is selected, and here in the signature editor, the third icon is defined the create new signature from the AOI. We have to click on this. Some issue is there in between. I just again reopen this image and then start again the part of classification of type of unsupervised. Make it raster. Three, two, one. Okay. Now I just go to the signature editor. Signature editor window open up. Now I just go to the AOI in the same viewer window. Select the tool. In the tool, I have to select the create polygon AOI. So I simply select it, and here I have to create new AOI. Now, yes, now it's come up in the as a class 1. As we have an idea regarding the particular type of the class or land use type, like this is the forest area from the standard FCC information, as well as we can also define based on our ground truth data sets. And always when we go for the classification using any kind of image, choose the same kind of polygon from each corners or best possible of every direction of extent, but in particular kind of length class. Now I again click on the particular polygon, zoom in this particular area, which is also a forest area. Okay, we have to make a complete polygon, and on the final click we have to double click on it. Now it is already selected, and in the third icon, which may define the create new signature, it's already added up. Like this, we have to select at least bare minimum, you can say at least 5 type of classes of the same type of land use. Now I just zoom in this particular this area. Again select the particular create AOI polygon, zoom in and select, double click on the final selection, then go to the signature editor and the create new signature from AOI option, click on that. Now come to this other side of this image also. Here we can select the create polygon, zoom in this particular area, double click on that, insert in the signature editor. One more class I have to add in the same forest class type. And add up. Now these are 5 number of classes are there, which we already have information that these all are the forest class based on the information or visual interpretation, as well as, or you can say the ground based information, what may be the kind of information we have. Now these all have the same class, like you can say the forest class, so we have to select all like this. By the left cursor you have to select all, and in the 5th option, which defines the merge selected signature. So now this is your merge option. It simply merge all these 5 classes and make it the final classes, and this final class we make it as a forest. Okay, now rest of these 5 which is already selected, we have to delete the particular selection. So this particular kind of forest class, the signature name is the forest, which is as color shows as a dark green color, and we make it the total 5 polygon of forest class. Like in the same fashion, we have to select best possible 4 or 5 AOI, or you can say polygon, with respect to all possible land use classes in the described area. Now come to this next, like I want to select for the river bed, like go to the river water body. So again I have to zoom in this particular image, where is the water pixel is available, go to the polygon, then insert. So this is then again make it that like class 1. Then here this is the water body, again create AI polygon, select it, insert it. 2 number of classes are there. Then where is a high, you can say a broader streams are there, you can select based on the DN value, or you can say the FCC which is there on the image. Zoom in this particular any specific area which shows the same kind of land cover, select the particular polygon, we have to zoom in this side of the same dam area of in particular river, part of the Yamuna river in India. So again the create polygon, here select and the final create on double click, make it as a selection option and insert in the signature editor. So like this, we can select it, select the all 4 classes, make it one class and make it rename as a river. Like this is the river body. So we make it a river as rename it. And remaining class 1 to 4, which is already merged in the river signature name, signature. So we delete the particular other selections. So now we have 2 signature with or based on the different selected AOI. Now come to this the third class, like this area, like as I already discussed in start of my demonstration, like this area has all possible kind of land use. There is a part of mango orchard also and tea estate or tea orchard area also. So we select the mango orchard area best possible in the same image and make it a further class name as orchard. So simply select the particular polygon, insert it, then again create polygon, then insert it. Here you can see this area also comes under the orchard area based on your ground based information, or maybe you can say high resolution image, satellite imagery. Select on this. This is the third number of the AOI of the particular area, or sorry, particular area in particular class type, like as we selected for orchard. And here one more polygon I just want to make it, and this is to make it inserted. Select this class 1 to 4, merge it, rename as orchard, and other selected we have to delete the selection. So there now we have the 3 class in the signature editor. Now the 4th class is, as we define, the agriculture, or you can say agriculture or cropland area. So in between the pinkish tone is defined you the agriculture landscape, because this area is prominent for the sugarcane in particular kharif season, or you can say the monsoon season. The prominent crop is paddy and sugarcane. So there is a dark to slight pinkish color is defined the area of paddy and sugarcane crop in the area same. So we have to select based on the particular tone type, or maybe you can say GT point information. Make it the polygon, select, insert in it. So we have to zoom in this particular area thoroughly and define where is the best possible classes based information of respective class. So again I just zoom in. This is a field. Again I insert here. I just again make it color, change the color combination for the particular forest and the orchard. Then further I define for agriculture area. So again I just zoom in, make it zoom in an area, select the create polygon and insert in the signature editor. Because this is the riverbed alongside area which is more prominent for the crop production. So based on that, I just choose I wisely choose a particular area which has the particular kind of agriculture type. Again, I have to zoom out and select from the other part of the image, like this area also, which has also along with this seasonal riverbed area and also has the agriculture landscape. Like this is the agriculture landscape you can see. So you make a polygon here also which you define as agriculture area. So like this 5 class we make for the crop. So I simply merge the all, rename as a cropland area. and other selected, we have to delete the particular selections. So cropland, we just make it as, you can say, the yellowish in color. Now the next type of land cover, or you can say land use as we define on the particular area, that you can select settlement area. So now we have to choose the settlement area or urban area and make it a separate signature. So for that, again, I just make it, we have to wisely choose the cluster of homes or area, urban area. We have to just make it here, like here, it is the urban area. Once insert it, again make it polygon here. This is also a urban area, or you can say settlement area. Then we have to zoom in on other side of the image, select the AI polygon, create a polygon, make it the final selection with a double click, and insert in the signature editor. Again, go to the AI selection, select the particular area and insert in the signature editor. So we select on that side. Now we have to come to a little bit, zoom in other side of area where we can say a little bit settlement are there. So there is also some settlement part. So we have to wisely choose and insert it. Now we have to select all price classes as we define for urban area. So I just rename as urban, and rest of the class, which is already merged in the urban, we delete it. Now the next class in the particular area, we can select, we can select the fallow land area, because in the agriculture area, it is not fixed that all cropland area is covered by the crop in a particular season. So there may be also possibilities or chances to be a crop, to be a type of classes as fallow land area. So we have to choose the fallow land area in the satellite imagery based on the ground truth data sets. So like this is, we can say this is the fallow land area in the particular satellite imagery. Insert it. Again, create a polygon. This area also looks like it's a fallow land area from the particular image. And these all are information we have to acquire based on high resolution imagery, or you can say already classified image as a, you can say use maybe reference image, or ground based ground truth information, GT point information based on like the latitude, longitude, location basis informations. You can say there also, this is also the fallow land area. We have to select the polygon and insert it. On other part of image, we can select on other side of area also, like this area also. Here we can select then insert it. One more type of, you can say, like here also based on the color tone and texture, we can wisely choose a particular area and select it and insert it. Now there is a 5, so I just make it merge and rename as a fallow land area. And remaining here, I just delete it. One more type of class we can select here, like the most prominent in the same image, satellite imagery, that may be the riverbed area, which has a little bit higher extent of area along the river side. In the here also you can say here also as well as on that side. So according to that we have to wisely choose the area of dry riverbed area. So again I just create the polygon, select it, insert in the signature editor, make a polygon, select the area, insert in the signature editor, then move to the lower side of the river, make a polygon, create, double click on final selection, insert it. There also a higher extent of river bed area is there, dry river bed area is there. Select it, insert it. And one more class I have to select, and that should be from other side, like this side we can select. We just simply zoom in, this, okay, and insert it and make it all select, merge it as a final class and make it name as riverbed area. Remaining selected, we make it as a delete selection. So now we have total 7 number of signature, the name as like forest, river, orchard, cropland, urban, fallow and riverbed area. So this is the best possible, you can say, the type of land cover, land use available on this particular area. Now I simply change the color scheme of this particular type of signature. Urban area, I just make it as cyan. Rest of it is okay. So now come to this, because this is a vital information which may further use for supervised classification. Okay, so we have to save it. For the save, we have to go to the file as, make it the save as, and in the save as we have to select the particular folder where we want to save it. And the same, which I just mentioned, like this is my signature, okay, and that is the formatted .sig format, and okay. Now the next thing, we have to define how much signature separability informations are there, or signature separability is there, as we already wisely choose that all sort of AOI, or you can say polygon from the particular imagery, from all sort of, you can say that all corner of north, west, east, south, all side of image, but it is quite separable, yes or not. So for that we have to go for signature separability analysis part. So in this we have to define like contingency. It is an option in the evaluation. In the evaluation there is the option of evaluate separability. So in the evaluate separability, like based on the information of how much information we have to assign here, we can define the separability information that we can calculate from here, as well as we can define the contingency. And in contingency, like what kind of parametric rule, like here we use paraploid or maximum likelihood classification, which is mostly used for a parametric rule of the contingency matrix formation, as well as the classification algorithm in supervised classification. So like this also we can generate the contingency matrix, we can generate it, and now yeah, it's generating. So you can see like error matrix, it is for just for the reference data, as we mentioned, or we are using for the classification. So it will be best possible, like forest area, for river area, orchard area, then cropland area, then urban, then fallow and riverbed area. How many pixels are there in terms of reference, and the further their error matrix based on the particular process. So like this, we can generate this very basic of, you can say, separability analysis as well as the contingency matrix generation. One more thing we can generate here, that is to create the feature information. So for that we have to select, go to the feature option. In feature, go to the create and feature space layer. Okay, so in the feature space layer also we can define how much separabilities are there in terms of total selected AOI, or you can say the pixels with respect to each and every class. So this is the for getting information or creating the information of the feature space from the particular image, and we have to define how much feature space are there in between one class to another class. Like as here we have selected total 7 number of classes. So what may be the differences between class with 1 to 2, then 1 to 3, 1 to 4, 1 to 5, like how much difference between 1 and 5. So the separability, the feature space define how much separable or clear distinct separable features informations are there from this create space feature information as from here. Now this up to we have selected the part of signature, various signature, like number of classes are 7 as we have selected here, and we come to this next step, which is the supervised classification. So for the supervised, again go to the classifier. In classifier, go to the supervised classification. Here I have to select the particular image. So I have to select this particular image, which is I simply use for classification as a row image. Select the input raster image in .img format, yes. And final output format, as I selected here, that I just make it supervise underscore for the October image. Make it okay. Now here the input signature file, which we are already saved as in form of this, which is created from generator of various kind of AOI, area of interest with respect to various kind of classes or classes type. So here I generated signature file, select. Okay, and here we just select the parametric rule, that is the maximum likelihood classification, like best possible to select the particular DN value based on the AOI which we selected with respect to particular kind of class. So their maximum likelihood classification. So based on that, based on maximum likelihood parametric rule, they define the classification rule and define the particular type of pixel, like in which class it has to be put on, like where it is lie. So that is all about this. We added the image of input image, final classified image name is there, then input signature which is already saved, and click on OK. So the processing was going on, and now it's completed the classification part of supervised classification. Now I have to just simply close it. I again open a new viewer window, open up, then add up here our classified supervised classified image of same October image. Now you can see this is the classified image of the particular area, as we select the various kind of signature based on various ground based information or arbitrary information as we have information regarding the particular area. Okay, and here you can see some of the or forest pixels are mixed with, like the low pix mix is this particular. This is a limitation, or you can say the disadvantage when we select a less number of polygon, like here I select only 4 or 5. So we have to select more number of polygon with a precise location, then it shows the exact information or classification output. As I just show you a classification output of the same area, it is look like so, and which is same resemblance for the particular area specific. So now come to this accuracy assessment. Now no doubt when we are doing this particular kind of classification, that is no doubt it's a tedious job and it's a time tracking process. So we have to wisely select each and every point and each and every steps one by one in a very precise manner. Selection from the GT point up to the final classification algorithms or the AI selection in the signature editor part. Now come to this, I just close up that part. Now I just open a geospatial light table where we can open two tables along same time, and we can link up both the images also. So here I just select, right click, their option is there, open layer. So here I just select the already classified image of the particular area specific, right to, and you can the image to window. Here I just open our classified supervised classified map image here, which is look like so. Now come to this accuracy assessment part. In the accuracy assessment part, as it is there in signature editor itself, first we have to link up the particular image so that when we compare with our already reference image with our classified output, so we can make a same resemblance or same, you can say, location basis information, and we may compare each and every point. So for that, I simply select this option. One option is there in the same, that is the link option of the geographical user. So I just use this. Okay, so now this complete image is selected. That is so. So where we can zoom in, the same area may zoom in accordingly. So again, once again, I just make it image to window here and image to window here. Okay. Now come to this part of accuracy assessment. So in the accuracy assessment, again I have to go to the classifier. There is an option here, the accuracy assessment. So in the accuracy assessment, you have to wisely select or wisely go through one by one every steps. Like here, you have to first open up the particular the IDAS image in viewer portal and image, and open up the image of your classified output as well as your reference image. Reference image may be your satellite, your high resolution satellite derived image or satellite observed image, acquired image, or you can say already classified image from the same area using the other type of sensors or other type of, you can say, spatial resolution based data sets, or you can say based on the information of ground truth data sets from the same area. So for that, very first you have to, in the accuracy assessment part, you have to go to the file. I just go through one by one all the points. So very first you have to select the file. Open up, that's the file here. Supervised classification. Okay. Then you have to select the select viewer, which viewer you have to select for the particular. Like I want to select this for this particular viewer point. Now come to this option of edit. In edit option, there is a, in the view, select, as you select the viewer. Now the next point is the change color. Like this change color define points with no reference and with point with reference. When we reference it in the reference table, then it's automatically become yellow. So like this, that yellow to white, that also we can change based on our our preference of the color scheme, or you can say from the particular image. Like you can say here, you can make it say black. Okay. Then change color, we can take it up. And now come to this part of edit, where we have to select the create add random point in our classified output. So in the same, like we have to generate the random points, and that random points we have to generate arbitrary. Like we can generate here, for example, like we generate here 15 points, 15 from the particular image, and distribution always on the random basis. Select OK, and all 15 points are now it's shows here in the same accuracy assessment window. So as we generate the random points, it is shows here. Now go to the view, and view when we have to define the show all point in the image. Now you can see here, you can define the image, the number as it is there, like ID number 06. So sometime, like you can say, based on the color, it is not showing here, or it's not visible. So we can change the particular kind of color also, like here, make it, we just make it red. Okay, now it's visible with you. And some of the points, because it's based on the geographical location basis of the particular image, so that and the point are on the randomly distributed over the image. So it may be sometime the points may be outlier from, or you can say exceed from the boundary of our satellite, or even satellite image or the type. Like here, ID number 2 is out of this particular. We have to wisely check, thoroughly check each and every point where it is all are realized in the image, and just check it out where it is. So when check it out, all are within the image. Now we have to compare with this one by one point number, all the point from the corner side too, or you can say other side also. Okay. So like this, as I compare from this particular reference image, very first as I choose is this my 13, ID number 13. So ID number 13, we can say what kind of color scheme, as we shows here, we make it as a right click here, fit image to window. Just a minute. So here, like as we choose this particular point, just wait a minute. Okay, so as we select the total number of signature in the image, there's total 7 class as we select, started from the forest, followed with the river, orchard, crop, settlement, fallow, and riverbed area. So accordingly, we have to select the same as per the reference image. So for that, I just open one more window where you can easily see the things what is going on. Like if I just open the reference image, just go to this right click, image to window, which is we make fit this with this particular viewer option. Go to the raster and attributes. In attributes, you can easily see here's total 7 number of classes in the reference image, and which is the number as the 1, 2 to 7 from forest, river, orchard, as I already named it, from 1 to 7. So same we have to follow in our class name. Okay. Okay, in the reference, what is the in the exact reference, and the same we have to define in terms of class and further go for classification accuracy. So if I zoom in this particular area, it's take little bit time, so just take a patience on with when you go for this classification type. Like 13, as it is mentioned in the classified output is 13, and here also okay. So like we can make a resemblance with this particular same image, like our here ID number 13, as we select very first 13. So what is the exact number in the reference, and that is the which is the class as we define. So in the reference we can say what is the number of 13, it is same as is the same color of red, which is a defined in color scheme also. Like red color define the forest area, so same the forest is there. So we can see it's a class number 7 because class number 1 because our forest class is, again make it here, that make little bit visible to you. Yeah, so our class number 1 is the forest, so we just select 13 and 13 it shows here, which is now it's automatically become black as I name it as the reference number, the reference class number. Now come to the 6 here, you can say in the same image it is look like here, and which is a I wisely choose little bit that particular zoom in with this. If I choose this 6 number, and 6 number it is here, it's defined me the light green color, and light green color in my signature editor, light green define me the orchard area, whereas actual it is orchard area, same which is follow up in the same area specific as we define here. So we can say with the class number of 6 which we select it orchard, and orchard number is 3. Okay, if we add up what is the exact in image itself also, so we can say directly here what is the show class, the show number, the class name is there. And here ID number 13 is 6 in our class, which may make it class number 6. Once this is my raster attributes, and where is my signature editor? Yeah, this is my signature editor. So signature editor value, as we can see here, class 1 to 7, and here also the class 1 to 7. So we have to define based on this particular comparing of reference image as well as our classified output based on their number of the same, which is it is there in our already classified image, reference image, and our supervised classified image. So like this, based on that we can select like arbitrary, or from this particular image we can select what is the exact number of this. Like 6 is reference, is the reference, it is the class number 3, and my class number, as I mentioned, it is the class number 7. The class number is little bit on higher side. Just we have to confirm from this. Okay, it shows me the value of this, which is 7, 9, 6, 7, 9, 11, 10. It shows me the value of up to 2, 10 and 11. So based on that, we have to select the particular class name. Oh, sorry, the class number in the reference image also. So like in the reference image, it is same. For example, if I just make it 7 with this, so 11. Based on this, we have to just zoom in one by one each pixel, as well as the information of the ground truth data sets. Once I just select it, like when, for example, for 14, you just make it like I classified it as a class number of 9, and here it is not class number 9, it is 8. So once as I name it 8, it automatically changes in the color here in ID number 14. So like this, we have to select one by one from our signature editor file. Little bit, I just zoom out so you can see all our possible points, which may define you our search count, and that search count is 1024 in when we mention in our random point selection part, and ultimately define the accuracy assessment part for the report generation. So like this, if I just make it my point number here 7, which is, if I just make it here, sir, I simply minimize it and define it with so which is, for example, point number 10. Point number 10 is a class number 9 as it is there, which is same, it is for my class, so I must make it 9. Point number 11, that is my point number 11. Yeah, this is the class which is as we define in the near to the our urban area, which is same, which is here as a 9 number. Now point number 8, which were defined as 8 number, which we define as a cropland area, and in 8, which is not exact, which this, so it is little bit deviate from this exact point. And then point number 12, it is point number 12, we have to select it, which is 10, and which is the same, the area of the class type. Like this, some point maybe because of as we select on the polygon basis, some point rely on the exact we are defining the class reference point, or sometimes the point little bit deviate from it. So it's little bit take time. We have to multiple iterative practices in the same and do the classification for the particular type of like supervised classification using the Padlappoid algorithm with final accuracy assessment part. So same, if I just go through the ID number 4, which is here, which is resemblance in the cropland area, and which is same, it is so 9, ID number 3, ID number 1, which is we are defining the forest area, but it shows in terms of plantation crop, which is not so, and our orchard number it is in 7, and the forest it is in terms of 6. So like this, we have to select the particular point. So now it is already there in all the classes in the reference. Now we have to generate the report from the particular class of class and reference. This is our like classified map, and this is my reference map. Based on that, we have to generate our report. And in the report, we have to further go for There is option is error matrix. We have already selected the error matrix, accuracy total and kappa coefficient, and further already selected, and you can like deselect it also, but I want all the error matrix information also, accuracy totals also, and kappa statistics also, and generate the accuracy report. So like this week the accuracy report is generated, that how with the pixel to pixel information all sort of generated. Ultimately it's define you the, because some pixels are deviated from its exact value, that's why our overall accuracy is 64.29% only, and while the kappa coefficient is 0.5513, because some of the pixel orchard pixel mix with the forest plantation and some of the urban pixel mix with our dry fallow land area. That's why our accuracy is little bit lesser in this particular imagery, and when we compare our classified or supervised classified output with supervised classification. So again, if I open one by one all sort of image here, like very first our row image, and then we can further compare in images also. Just make a combination of 3 to 1 as a standard FCC. Again, I open a new window, and here I open my unsupervised classified map, which I classified, but further not rename, or you can say change the color scheme. And in the same, if I want to open my supervised classification map, here it is look like so. And if I open a reference image which is already derived from the other data sets or same kind of data set from the particular area specific, so it is look like so. So like this you can compare in between the images also, from its visual interpretation part up to the unsupervised classification, supervised classification, and further their accuracy assessment based on the reference image. So I think this is all from my side. If you have any query, you just please let me ask, we may discuss, because at least if you go for one by one all the parts, a little bit it take time, but by the time it may increase the accuracy part of that. Yeah, if you have any query, you just text me. Okay, so one participant asked me, how can we do hands-on? Yeah, we will provide you. We will provide you the handouts also, as well as the data sets with you, the classified, the reference data sets, as well as the raw data sets. So you can try each and everything with yourself also. All the manual details are there. Like I just show you the things. So I just stop sharing. Then I show you the camera part. Yeah, we have the manual with us. We just share you the particular manual. All the steps are there one by one with the processing part and their details, the algorithm details, all sort of information are there in the manual. So the data sets manual, all the things we will share with you in our LMS portal by the meantime. Don't worry about the things like about the data sets. Any other query regarding?
Thank you, Abhishek. Thank you for the like very elaborative practical stepwise. You have covered all the things. Yeah, any practical related questions, whatever Abhishek has discussed, if you have any question, you can just put it in the chat box or raise your hand.
Okay, one participant asked there how to add image to software. So I just again share my screen. You simply go to this, like if I'm talking about this ADAS imaging software, go to the viewer, click on that. A classic viewer, you have to select classic viewer, click OK. The viewer window will open, and here directly you from file you can open up the data sets, or directly this first icon, which is the add the data sets open layer. From that also you can open, then you can, or you can right click and get information regarding that, all sort of. Like here I have to drag up all that one by one where I just save the data sets, like capacity building. In the capacity building I save facial courses, Steve, the image, okay, and it's look like so. Raster, then again make a combination of 3, 2, 1 from the same raster and raster to band combination, like this you can. One participant asked that one question, like yeah, we will share with you all material and software, all the details with you, don't worry. One participant asked, is it possible to combine unsupervised and supervised classification method? The classification method combination is not possible, but we have to add up the unsupervised product, unsupervised image and supervised image based on their image or count number value, or you can say the class number value. Because nowadays people, or you can say researcher analysts, are using the hybrid approach. So in the hybrid approach, you can say the classes like which is not the changes over the period, like river bed area, or you can say that forest area. So they simply classify using the supervised classification and make it you can say digitize the particular classified output, then further generate using the supervised classification, then overlay it, and then mosaic it from the supervised classification product or result. So like this they make in a hybrid approach, not exact the merge of the unsupervised and unsupervised classification method part. One participant asked, what if the training data for classification is in shapefile? Is it possible to automatically extract class sample using the features in the shapefile? No doubt you can directly extract the data set, but there is a limitation when you open up the image and the overlay your GT points or your shapefile, it's shown on the particular image. Then you have to digitize the particular point on the particular respective image. Then you have to make it as a AI layer. So like this, there is a very minimum job of just a few hours, but you can add up on this and you can generate as a shapefile and further use for your classification part. Any other query from student head? Few of the students, they are asking about attendance and eligibility of the certificates. Ma'am, Deepanita ma'am?
Yeah, 1 minute.
And if you have any query, you just please text in the chat box.
Yeah, so see, this is only a 2 days training program. So many people are asking about the attendance, and the people are still joining. I think the class is almost over. We'll have a very small session on SAR data processing after this. So I think you please strictly join the class in time. You have only 2 days session. So the first day is almost coming to an end. And again you have on 7th. Tomorrow there is no class. Okay, 7th morning you have the practical classes first. So from 10 to 12:30 you have the practical, and then after post lunch you have the 2 theory classes by two very eminent speakers. Okay, so please join the class in time, and then your attendance will be automatically taken care. Don't worry about that, right? Any other question related to the practical now, or we'll move on to the next session? Any other query? Somebody is asking about the e-class link. No, e-class link. Yeah, the schedule is shared in that site also. You have a schedule in PDF format is shared in that. So time zone, the current time zone we are following is the Indian Standard Time. So 10 a.m. means Indian Standard Time. Rest according to your location, you can convert it. It is clearly mentioned in the time schedule, which is already posted in this portal, eclass.irs.gov.in. Okay. Okay, Abhishek, thank you once again.
Thank you, ma'am.
So I think, are there any other queries related to the practicals?
I think
Okay.
not still, I think.
Yeah,
nobody-
so
yeah.
you'll be, we'll be sharing the material soon, and so you can do the hands-on in your systems. And also a practical manual and the material will be shared soon. Okay. Okay. Is my screen visible?
Yes, madam, your screen is visible.
Yeah, okay. So some little overview, around 15-20 minutes, we'll have a small overview on the SAR data processing. Actually, tomorrow, on 7th, you will have a detailed lecture on SAR data processing and your remote sensing applications for rice crop mapping, in which both SAR and optical data processing will be covered in much detail. And also you'll be having a hands-on using Google Earth Engine, okay, on 7th morning. So, but this part I'll be dealing with some basic steps which are really different from optical data processing, so that you have a wide overview and be ready for 7th lecture. Okay, so from where you can download the data today. Okay, today most of the users are using Sentinel-1 data globally, and you can download it from the Copernicus site. I have written the site address and all, and the basic processing steps include these few steps. First, you have to apply the orbit file correction, then go for radiometric calibration, finally speckle filtering, terrain correction, and registration, co-registration if you have a multi-temporal data. And the final step, you have to convert into decibels. Okay, so whatever data you are actually having in optical or in SAR, you basically have a DN number based data. So once you want to compare it with multi-temporal scenes or multi-site scenes, you have to do calibration. So that these steps are mandatory. Okay, these steps are mandatory for each type of applications you want to do in agriculture or elsewhere. And so some of the steps I'll just show you. So all these steps are actually carried out in, I'll keep this document also, I'll share this document with you. This I'll keep side by side so that you can refer to this also. And we'll actually work with the Snap software. So this is the Sentinel applications platform. It will ask you for plugin updates and all. Just I am showing you the initial steps so that this is a freeware. You can download it. The current versions gets updated. And it will always update the plugins, but you should have an internet connectivity for that. It will take few minutes only. Just let it continue. So in the first steps, you have to apply the orbit file. Okay, orbit file correction has to be done. Let me see this. I'm just opening one product. Okay, it is still in the process. So this is this zip file. If you can see this zip file, this is the Sentinel-1 data. So this is the data set in the Product Explorer. I think my screen is visible. You can see the Snap desktop, right? Everyone can view the Snap desktop. Okay. So this is how the data set looks. You have the metadata. Okay. You have the vector data in this. This is already geo-corrected level 2 product. Then you have the tie points, you have the quick look images, and you have the bands. So you have both the amplitude and intensity bands for two polarizations, that is VH and VV. Fine. Now the first step is applying the orbit file. So this is the data set, and where you want to save your output. So just you have to define this. Already this output remains. So let us just override this to see you can see the processing. So it is writing the product, it takes little time. So, but initial few steps I can show you. Otherwise, we'll share the hands-on material, and also you'll see the Google Earth processing on day 2. There you don't have to download the data, but you can do it in the Google Earth engine. So the orbit file corrections have been applied in the first step. Okay, so this processing has been completed. So here you can see the first one was the product file, and the second one, the ORB, already orbit file corrected image has come here now. Okay, now the next step is the radiometric calibration. So it is doing the calibration for both the polarization VV and VH. So in Sentinel-1 we received dual polarized data. You might be aware, like VV means you are transmitting in V polarization and also receiving in V polarization. But VH means you are transmitting in V but receiving in H. That is called the cross polarization. There are benefits of applications of both the polarization actually. For vegetation or crops, mostly the cross polarization response gives the volume scattering and the vegetation responses more dynamically over the crop growing season. VV polarization, it gets saturated earlier actually. So that is the advantage. Participants, you can see the processing steps going on in the software. Ravi, is it visible?
Yes, madam, it is visible.
Okay, fine, fine. So this particular software is a freeware. That is why I am showing this. Anywhere you can get this in your machine, and you can get the dataset is also free. Sentinel datasets are free. You know that. Only you have to download it and process. See, there are some advantages over Google Earth Engine. It has full polarimetric support. This particular software. In Google Earth Engine, you don't have polarimetric support right now. And also you can use the other spaceborne SAR datasets are also supported by this particular software like RadarSat, ALOS Pulsar. Okay. After the calibration, you will be doing the speckle filtering. See, this particular step is totally different. You don't need such filtering, speckle filtering and all for your optical data. There is some inherent noise built up in the SAR data actually due to its processing. The image itself is formed by certain number of steps actually. Unlike optical data where you don't acquire or get the image directly from camera, the pulses are recorded and then the image is formed at a later step actually. So due to the coherent nature of this beam and there are interferences, this speckle noise actually arises, and also it is also known as salt and pepper noise. So unless and until you get rid of this noise, it's very difficult to carry out some of the applications. It will give you very salt peppery kind of look in the image. Okay, I'll show you when before speckle filter and just a minute. So just to quickly show you, I have captured some of these images in slide form because each step takes quite a long time actually. So this is your first step, and you can see the image, no? You have a very salt grainy type of appearance. So after you do speckle filter, you get little bit smoothened image. So this is after speckle filtering. Okay. So how it is basically done? It is done using, this is again a capture of the same thing what is happening. It is going at the back end. So I have captured some of the images just to discuss. So adaptive filter is actually applied. Okay, it is different from the non-adaptive filter what we generally use in other remote sensing applications. For getting rid of the speckle noise, we have to use adaptive filter, where actually your basic edges of the image is preserved actually. Okay, and there are number of algorithms which take care of this. Your image edges and the spatial properties are not compromised here. So there are a number of filters available. The Lee filters, the refined Lee, the enhanced Lee. After the Lee, his work is like he made enormous contribution in this field. Even polarimetric speckle filters are also devised by him. So after applying the speckle filter, you see this grainy appearance has reduced a lot. If you compare this particular image, which is without speckle filter, and this image, you can see it has been smoothened and you feel a smoothened image. So let us go back and see in the software what is happening. It is still doing. It is doing the calibration part. It will output the image in your sigma naught domain for both the VV and VH polarizations. So it takes little time. Okay, so after speckle filtering, actually you have to do the terrain correction. Okay, so then you get this kind of rotated image after your geometric correction and all, and then you can do co-registration. Fine, because co-registration is required when you want to work with multi-temporal data. You have a crop growing scenario, right? So you have a first date data maybe collected during June or July when the crop season starts. Again after 12 days you have another data set. Again after 12 days you have, so every 12 days you get the Sentinel-1 data. Okay, so when you acquire, you process till this step, still speckle filtering for each data set individually, or you can devise a processing chain, and then you have to co-register these 5-6 data sets so that you do a dynamic temporal analysis, okay, of how the crops are growing to measure the different parameters and all. So therefore this co-registration is needed. It takes a quite lot time. So this is the co-registration process, and then finally you have the co-registered data set. Okay, so the processing took almost 100 minutes. So it may not be possible to demonstrate it practically over here, but you can carry at your end. This software is also available, and your data sets we will also share. These data sets what I am showing now, will share it on LMS. Okay, you can use the same data sets. Okay, now this process has been completed. So here you have the, see it keeps on piling up. So you have the calibrated file. So what is there actually we can see from here, you have the bands. So you can see the sigma naught VH and sigma naught VV has been created. If you want to view, so this is the image. It will load, it takes some time. So this is sigma naught VH, okay, the calibrated file. After this you have to do the speckle filtering. So here you can see speckle filtering. First let us do single product. Okay, so the last one, the calibrated one. Okay, sorry, we have to define the processing parameter. Just you have to select the type of filter. So Lee sigma is already selected. You have so many options. You can select Lee, refined Lee. These are all your adaptive filters. Okay, so you can just select refined Lee also, and then you can do, let me do just it for one band right now. You can repeat it for the other band. Okay, I'll just overwrite because we just aborted the process for selecting the filter. So it will take some time, okay, because these are huge images actually. And because you are using many information from the header files, so it is not always advisable to subset the data at the beginning. Okay, at the beginning you need not subset the data, but after certain processing, suppose you want to clip a small area and proceed, that is always possible. Fine. So this particular data has a large swath, okay, and resolution also, you know, it is 10 meters around. So the pixel spacing, the azimuth and resolution are different. Some of the theories and these things will be, applications will be particularly these things related to agricultural application, not the very basic SAR processing. Anybody interested can go through manuals of remote sensing. So the volume 2 is totally devoted to radar processing and various applications also. It will take some time. So meanwhile, if there are any questions, I can take up this processing, because the basic steps I have already explained to you. The processing will take some time. Any questions you can just put in the chat. Any queries? The important steps I have already shown you the hands-on. You can do it yourself. Okay, because the co-registration, the next step is co-registration. That will take long time. It will take around more than half an hour or 40 minutes. So I'd like to hear if any queries are there. Your processing for speckle filtering is going on. It's not even half over. Okay, so it will take some time. The selecting the filters is based on the application. See, mostly for agricultural application, refinedly, enhancedly, these filters have been established to work well. So using a filter size of 5 by 5 is okay for this kind of data set, or even 3 by 3. If we use a very high filter window, your data will be smoothened beyond your like analysis. If you smoothen it with higher size window, it will be smoothened too much and you will lose the finer details actually of your fields and other features. So 5 by 5 window has been devised to be okay for agricultural applications. Any questions, please you can put in the chat box. Okay, specific system requirement. See, basically SAR is a voluminous data, and RAM, 8 GB RAM or more. Okay, 8 GB RAM is must for processing. Okay, so otherwise your even 4 GB RAM also will support, but it will be very slow and it's not recommended actually. Fine. Otherwise, there are no other, the current version, whatever you are having, desktop or RAM is basically required actually. Yeah, so in your systems, you can just start downloading the software and processing. Okay, GIS software, yeah, the QGIS you can do part of the SAR analysis, but see, as I already mentioned, that these tools must be available. Okay, the SAR calibration, speckle filtering, and also SAR specific softwares are there are ample quite number of softwares actually. Eradas does not support SAR data as such. You can do few processing. See, after you prepare the data, you can go there and do the classification and all, as Abhishek has mentioned. Okay, but the initial data pre-processing till co-registration, you can take a multi-date stack and then you can go to Eradas and do some of the processing, the classification and all, no issues. But the initial steps, no, what I have been showing, which are very different from optical data processing, that is not supported in many many other softwares. Yeah, QGIS and one ISRO IGIS is there. There you can do it. Another good software, a very versatile software, I'd rather say, is PolSAR Pro. Again, that is also developed by ESA. That actually supports the polarimetric SAR data very nicely. You have all in innumerous number of parameter generation options and applications in that. And also SNAP is also a good one, whatever I am showing right now, because this is specifically meant for Sentinel processing. Okay, and also it supports other data sets as well. Radar set, ALOS, you can see here. And just by the time this is going on. You can see it supports NVSAT data also, and a number of polarimetric applications. If you can see, I'm just pointing to this. You have number of polarimetric applications here, SAR applications, okay, soil moisture studies, SAR utilities, all these things are there. And Sentinel-1, anyway, there are very rigorous processing steps are all available. Whatever you can think of with Sentinel, every processing steps, it supports all types of Sentinel data. Sentinel-1 as well as Sentinel-2, we have a separate module for optical. Okay, right now we are discussing the radar module. Okay, so you have quite a number of PolSAR Pro also. There are all support is there for all kind of spaceborne and many airborne sensors. The past airborne sensors also is supported by PolSAR Pro. That is also a freeware developed by ESA and team. Okay, so okay. Okay, then we'll, I'll just see if there are any other questions. Okay, NV, yeah, NV also supports, but not very rigorously. Some, yeah, Gopal Kumar R is asking. See, in NV, yeah, some of these RI set data we have been processing in NV also, but it doesn't have a very rigorous support in terms of filters, and few options are available there. Actually, there is a separate module in NV. You have to buy it separately. That is known as SARscape. Okay. So some person is joining now when the class is getting over. Please be careful about the timing and your this thing. I'm admitting somebody is joining, asking to join. Okay. NV has a SARscape. I'm just typing it for your information. It is a SARscape module is there in NV, which has a very rigorous support, but this has to be bought separately. It doesn't come with NV as such. Okay, like you have the flash for hyperspectral data processing. Similarly, this SARscape module, separate licenses have to be bought. Yeah, this has a very rigorous support. SARscape has a very rigorous support, but NV as such does not have so many options for SAR data processing. Am I clear? Yeah. Any other questions? Okay, so see your this speckle filtering is still going on. So once it is done, let us wait for another 5 minutes or so. Maybe this will get over. Otherwise, I'll just show you. I already have this whatever I was showing you. After the speckle filtering, you'll have a this PPT. I'll show you. Yeah, so after speckle filtering, you will have this kind of very smooth image. Okay, if you compare it with the earlier one, you see very grainy appearance. So if you apply some classification etc. on this grainy image, you won't get the desired result. Okay, these are some salt and pepper noise too much is there, in after speckle filtering you'll get this kind of smoothened image, and then you can go ahead with co-registration and classification. Yeah, so the processing has been completed. Okay, so just we'll view how the image has come. So it keeps on piling up one by one. See, if you can see, so this last one is yours SPK. This is the filtered image. So I did only for one band to do it quickly. Okay, so I'm just viewing it. It will come. Yeah. Yeah, so it is visible. You can see it has been smoothened a lot. So this is the filtered image actually, VH filtered image. I have done it for VH polarization. Okay, so likewise you can do it for VV polarization. Same steps, same kind of filter size. Okay, so you will get a just try. So when you have a multi-temporal data, you can carry out these steps separately for 3 or 4 dates, and then you can go for co-registration. So that will stack your images in a sequence. Then you can either go for any parameter studies. If you want, you have some model, you want to retrieve something, yes, or you can go for a classification. You can have a multi-date stack, take it to wherever, like you can do it here also. Here also you have some options. Random forest classifier is there and few other options are there. Otherwise, you can take it to NV or ERDAS of your choice, wherever you want to. Fine. My system has also, I think, given up. Any other queries? You can just put it in the chat box. Yes, somebody is asking QGIS. Yeah, QGIS also few options are there, no? But yeah, it can be customized. It can be customized, and one ISRO's own development. There we have a full radar tool also. Okay, it was specially developed at the ARISAT time frame. ARISAT was our own radar imaging satellite, which was launched in 2012, and it was there till 2016 and almost. So there will be a follow-on mission soon. So it has all support for that and for other radar sensors also, radar set and all.
Sorry for the interruption. I think the presenter got disconnected, so she will be joining soon. Please hold on. So good evening, participants. I think the madam's her presentation is complete. So we are wrapping up for today. So you can disconnect now, and you can rejoin on 7th, 10 o'clock. So with this, we are just closing the session for today. Thank you. Thank you all for joining this session. So goodbye to all. I am disconnecting the meeting. So I'll be dismissing the meeting. Thank you all for joining.